மேம் விசிபிளா இருக்கனா?
Yes, sir.
Hello?
Yes. Yes, sir.
ஓகே சார், கேக்குது சார். ஆனா பின்னாடி ரொம்ப பிரைட்டா இருக்கு சார். லைட் அட்ஜஸ்ட் பேக்ரவுண்ட். உங்க there is background very bright.
ஓகே மேம்.
Okay. Little okay. கொஞ்சம் ஓகே தான் நினைக்கிறேன்.
மேம் இப்போ ஓகேவா?
Yes, sir.
ஓகேலா மேம்? குட் ஈவினிங் மேம்.
Good evening, sir. Am I audible, sir?
எஸ் மேம்.
எஸ் மேம். மேம் யுவர் வீடியோ. ஓகே, தேங்க்யூ மேம். தேங்க்யூ மேம்.
Sure.
Ma'am, MC, please start, ma'am. Pushpa ma'am.
Yes, ma'am. Good evening, everyone. It's a great pleasure to welcome you all for this Atal FDP on the future of healthcare, AI-infused medtech innovations. A special warm welcome to our distinguished speaker, Dr. Gokila, Professor and Head MCA Department, Hindustan University. And extend my warm welcome to all the participants from different institutions and also the organizing committee. Thank you all once again for joining us. Now I invite Dr. Vijay Kumar to begin the program with the introduction of Dr. Gokila Madam.
Good evening to one and all present here. It's my pleasure to invite today's our chief guest, Dr. S. Gokila. Dr. S. Gokila serves as the head of MCA department at Hindustan Institute of Technology and Science, a prestigious deemed to be university in Chennai. With her extensive expertise in computer application and dedication to academic excellence, she plays a pivotal role in shaping the future of IT professionals and advancing the department academic and research initiatives. As the head of the MCA department, Dr. Gokila leading the design and implementation of a comprehensive MCA curriculum that integrates emerging technologies like data science, artificial intelligence, machine learning, and cloud computing. Mentoring faculty members and fostering a culture of research and innovation. She also ensuring the students to receive a quality education and industry relevant skills for successful careers in the IT field. She builds the strategic partnership with your leading IT companies to enhance the placement the placement opportunities and practical exposure. Her key areas are data mining, natural language processing, machine learning, language training, and data analytics. She got a Best Teacher Award received on Republic Day at the Hindustan Institute of Technology and Science in recognition of outstanding contribution to teaching and student development. As the professional affiliation, she got a professor award or professional placements in Hindustan Institute of Technology and Science. Her vision and mission provides a student with a strong foundation in mathematical, scientific, and engineering fundamentals. She prepares a graduate for advanced studies, research, and development roles. She develops tech-savvy software professionals ready for role as application designer, developer, tester, and software engineer. Foster innovation and independent thinking in the student. She also bridged the academia and industry to meet the dynamic needs of the IT sector. It also gives me immense pleasure to welcome once again our today's chief guest, Dr. S. Gokila. Welcome, ma'am.
Thank you, sir. Thank you for your wonderful introduction. Dr. Gokila, ma'am.
Yes, ma'am.
Please start your session, ma'am.
Yes, I thank the management of Vinayaka Mission and the organizing team for giving me the opportunity to share my knowledge in this platform. Thank you, Dr. Vijay Kumar, sir, for a warm introduction about me. So let's begin with one small survey to get into this. I know that you participants can give your response in the chat. See, always as a teacher, as a faculty, we have to get to know the level of the students, the input has to go accordingly. So the same to any level of learning. So I want to start in the same way to here. How many of you know deep learning? You can give your response in chat or whatever the reaction is possible in this platform for you. Not much, moderate, basic, yes, little bit, intermediate. I'm expecting at least 50% response over here among the total number of participants. Yes. Thank you all for your response, those who are giving over here. So somewhat you are having some little bit knowledge in that. That is good. How many of you believe that the mathematical background is required in this deep learning? How many of you say yes? How many of you say no? Mathematical background is required for this deep learning. Yes, of course, without that we cannot survive. It's correct. Actually, here you may be from the different platform, because in order to make use of this deep learning as an application level, or some of you might be going as the deep learning in a development level also. See, if you are in a development level, there also you have to understand how this is working, how in-depth the mathematical is supporting for that. So you can develop your own model too. And at the other hand is that those who are going to make use of this, because every model, every methodology is not the final forefront for any usage. So in such case also you should be knowing some mathematical working principle behind this deep learning in order to make this particular model as better for your requirement. Okay. So with this, let us get into the today's relevant topic content. That is the topic given here is the deep learning for the early detection of disease. Okay, let me share my screen and also to present. Then we slightly start with what, how it is. Then let us get into this deep learning. I'm sharing my screen. Please confirm whether it is visible to you. I hope my screen is visible.
Yes, ma'am. Yes, ma'am.
Thank you.
Yes, it is visible.
As I told you already, we are going to start with what it is. We always have to justify the topic. So first we have to understand what it is, what today's title is exactly about. Then we slowly move into in depth how these models are relevant to the field, how these models can be used as the best for your requirement, and how to enhance this model for a future development or a new enhancing models also. So let us go with what is deep learning. One of you have given a response that it's enhanced level of machine learning using a neural network. It's of course for all these, the fundamental is the neural network, how we are interconnecting the information. Always in our learning also we'll be saying that whenever any concept is being given, we have to interlink that with the other relevant information, what we grasp already or what we know or what we like to learn. Those things we have to relate. Then only it will be helpful for us to remember for a long, even any incident. Sometimes we may be talking about the attires. So we'll be connecting to the occasion. On the so-and-so day I was wearing this. So I may be remembering which suits to me. And at the same time, when I use this, So many other additional knowledge you can gain over here. So the interconnection of the information is highly important, and the basic neural network always goes with that. It is always connecting with the input and output, where the intermediary connecting processes, those hidden processes, or the learning methodology or learning steps it is going to be. Here the learning is of two kind. We always go with that, the supervised. As all of you having a little bit knowledge, you could have heard this term, supervised learning, unsupervised learning. In case of supervised learning, we'll be feeding the system with the both input and output. The system will understand both. For this input, what may be the output, what should be the output. So it is going to develop that interconnected knowledge through that hidden layers, and it is going to acquire the information. So later, when you are going to pass on only the output, it is going to, sorry, only the input, it is going to predict what is going to be the output. That is your prediction. So the initial training stage, when you are giving both the input and output, then we call it as a supervised. If it is a unknown information, then we'll be making the system to understand and learn and find the output in the initial stage also. So for that, it is always, this model is going to go on with these layers. Any deep learning model, it is going to be these three or a minimum. Apart from that, the hidden layers, what we are calling, right? The methodology going to vary in different models. Each model is going to have its own methodology of learning and the training, all that. So in such case, the hidden layer is going to have different logic. So based on that, we are going to classify, or we are going to list out the different deep learning models. And whenever we are going to train the model, see, even in our life, if I want to get more in depth in any of the concept, we'll be learning different authors' books, because the different authors' perspective or the way they are conveying the content may differ. So the same concept, one which was being conveyed by the user, might not be acceptable or learnable to me. So I can refer the other author book also. So there's some way. The same information, I may be getting it from the different author. The same to the mission also, of the deep learning models or a machine learning model also. We have to give an enough data set for them to learn and understand it. So different variety of images, or not only the images, whatever the input you are giving to train the model, that should be given. So in case of the deep learning model, whenever we are talking about the deep learning model, the thing which comes into our mind is the CNN, RNN, LSTM. Apart from that, it is having many other things. Why are we having these much different kind of models? Because each one is having its own uniqueness in this learning procedure, which is the highly important when we are going to learn. When I'm going to decide a model, which factor decides that this is the suitable one? Can you give your response? When I'm going to pick a model, which factor I'll be looking into most? This is the suitable model for my requirement. When I'm going to pick a model, which factor decides that this model very suits to me? Type of data set, it satisfied all the condition what we expect. High accuracy of model is, features, whenever we pick a model, our expectation is going to be its perfectness. So when the model is going to give you the high accuracy, then we'll pick that model as this model suits to me. But at the same time, as the model is giving me the high accuracy, at the same time, if it is taking a long time to learn, there is no use of that particular model, because it is taking long time. We want to give a quick response to the society. So if the model itself is taking a long time to learn, how it will adopt for the new input and it will give me the correct outcome on that. So apart from the accuracy, how long it is going to take to learn the system, understand the input, that is also important. So many things it has to do automatically, and at the same time it has to come up with high accuracy, and also that our expectation is going to be on a quick response also. So these are the few factors I'm saying, but some of you said it is going to be the data. Based on the data, I'll be picking a model, because here we are saying that right, the hidden layer is going to learn a data. Every model will not suits to every kind of data. So based on that, we have to pick one which suits to our requirement. One of your requirement is the model to learn your the type of data what you are. So this is a classification that we were talking about when I'm going to give only the input, and the system is going to learn, it is going to find the new outcomes, because I'm not at all feeding an output to that system. Then it is coming under the unsupervised one. If I'm giving both the input as well as the output, for this input, this is going to be the output in a historical. So by learning the historical data or the past information or a past instance, the system is going to learn, and in future it is going to do the prediction. And the next one comes into the reinforcement learning. So whenever the system is learning, we are expecting the good accuracy. The system has to give me the correct answer always. 100% should be correct. But in the first shot, the system may not give you the correct output. We'll be training, we'll be giving you different set of input, different possible inputs. All that will be feeding. So, but even in that, we'll be having some challenges in feeding a data also. So in that case, whatever the data I'm feeding into that, from that, the system has to learn, and it has to refine itself for the prediction. It has to correct by itself. So in such case, we will be going with the reinforcement learning. System is going to do something. It is like how we are doing a continuous assessment in academics. The student will be given some test. So if they are performing well, it is okay. If they are not performing well, we'll be giving them a feedback where they are doing a mistake, what they have to correct. So somewhat. So this is so if suppose if it is like a MCQ question later on, if you are releasing the answer, so from that answer, the student will be, but that is the later correct answer what they are getting. So from that, the student will be understanding that the what they have given was wrong. This is the correct one. So this is the way I have to think thereafter. They are self-correcting themselves. No, those kind of learning, it is coming under the reinforcement. So your deep learning model can be trained for any of this. That is what I'm saying. This is a different method of learning. For each of that, you can pick one of the deep learning model. And also based on the data, what you're going to feed for the deep learning model, for the model to understand and give a data, we have to pick the one. Now, we have completed the first part of the title understanding, that is a deep learning. Now we are going into the how this model can be connected with the disease detection. Every model can work on with any kind of data. To the title 11, we are going to connect the deep learning model for a disease detection. There are many applications. A few I have listed over here. Whatever the thing you are facing in the society, or you are getting to know about it, or you reading it, for all that we may like to give a solution in an AI model. So in those cases, we can connect, or we can build this deep learning model, and we can train this model for that particular disease information. That is, we have to have, even if I'm going to have a fever, we'll be identifying, or from our past experience, or how our body temperature is, the different other symptoms what I'm having. So based on that, if I experience the same kind of symptoms early, we ourselves will be coming into the conclusion, right? This may be this kind of fever. Or else if I'm going to have a clinical screening for that, so how long the fever, the temperature exists, what other symptoms I'm having, and all that. So by studying all that, I have to come to the conclusion, it may be what kind of fever it is. So for that, I have to train the system. So all possible symptoms, and what was the previous case for those symptoms, what were the treatment had given in the society or in that particular clinic, or commonly, if it is a common disease, how that has been treated, what kind of medicine have been given, all that will be having collectively information. So by feeding all that, the system is going to learn. So for this kind of symptom, so this kind of treatment, these are the medicines are being given. For all that, it is going to understand. So when I'm going to train the model in such a way, later on, if the same kind of symptoms are being given, your system can give me the suggestions or clinical predictions. This may be the treatment. But for all that, the initial training has to happen. So like this, your model can be trained for different kinds of diseases, but we cannot fix that one deep learning model is going to work for all diseases. It is not possible. As I told you, the disease reduction, this is generally we are talking about. But in the case that for particular disease, whatever the disease you want to work on with, or for which particular disease you want to develop an automatic system, AI model, that disease data you can take and the relevant historical information you can take, and we can pick a suitable deep learning model and we can train it and keep it ready for the future use. So when you're feeding the same kind of symptoms or other parameters or information relevant to that particular disease, to that particular trained model, it will be giving you the suggestions. But for all that, the early training is important. So the detection of disease by training the model, whatever the disease you are picking in, accordingly, we have to take one of the deep learning model and train it. And how can you make this as an early detection of the disease? It does not mean that so far I was giving you the example that the disease detection. These are all the symptoms. For this symptom, I already affected, so this was the treatment has been given. But in some cases, with the slight symptoms, I have to, I may need a solution to find a huge disease also. For example, it may be that maybe this simple temperature or a shoulder pain, it may be. Okay, in the society, it is a common statement I'm saying. It is not a clinically proven one, or it may be, the generally will be saying that no, if it is a shoulder pain, we'll be coming across with many other symptoms. So only by that symptom, I have to identify what may be the affected one or what may be the disease it is, what it may cause. Slight symptom, I no need to wait for another symptom to get generated in my body. So before that itself, I want to identify. So for this slight kind of system, I may be analyzing on a lot of things. For the shoulder pain, what other connected possibilities were there in the society? So I have to pick up one and I have to go on with all the other information. But see to that, this one particular information may not be enough to find the disease early in advance. So I'll be coming across with all the other clinical information of that particular person. When it had happened, how frequently it was happening, whether are they having any other symptom. It is not a new development of symptom it is. Along with the same symptom, what other symptoms the patient had felt. So all that collectively we will be taking and feeding to the system. That is your deep learning model. And also that your deep learning model learning strategy has to be different. So we have to train the model accordingly. It is not a standalone model always I'm giving reading and giving an output. It is not like that. So we have to fine tune and develop a model which can identify or detect the disease early in advance. So such a way we have to train a model. I'm summarizing over here. The deep learning model, it is going to understand the input. It is going to learn its own methodology, different learning methodology. It is going to understand the relevant input, output for the input. Later, when you are going to give an input, it is going to predict this may be the output later. So this kind of learning we can apply to the disease detection also. But if you want to make it early, with a less amount of symptoms, your deep learning model has to identify the disease, these kind of problem you may get in future. So this kind of detection is highly important for many life-threatening diseases. That is highly important. So in such case, the normal deep learning model, what you are having, the pre-trained one will not be sufficient. In such case, we have to work in depth in the model in order to make the model to think and learn in a different way to understand those symptoms and the parameters, and it has to work on. Now, let me connect one information in a technical term over here. Whatever the term I'm using as a symptom, right? Now we have to connect that into the deep learning term that is a feature. We call it as an attribute or a feature, input parameters like that. So I was giving you then a simple example that is shoulder pain. That's shoulder pain. Along with that, all the other information I will be feeding it, right? Whether I'm having the on that particular moment. I'm not talking about the new other symptom to get developed. So for that current information, current pain or current symptom, what other complications I'm having along with that. So all that we call it as a feature, the input parameters. So using that, we have to train the model. So in that case, you think in a doctor's perspective, they'll be linking it, right? If you're having a shoulder pain or you having a neck pain also. If you're having a shoulder pain or you having only on the left side or only on the right side. How frequently you are having it. So related to that particular symptom, we may be having all the other parameters. So those parameters have to be collectively taken. So this is one sample we are talking about, right? So like this, if I want to train the model like this, I have to take 100 patient data in order to come to the conclusion. Because everyone having the same symptom will not be leading with the same kind of disease. So these collective information will be feeding, and this relevancy linking we have to train to the model also. What are the parameters? If it is a shoulder pain or you having a neck pain also, these two parameters has to be connected. So likewise, the interconnected information we have to build. Here we are talking about one symptom, but if you are going to train the same model for others, other disease, these interlinking may not be sufficient. I have to work on with other things. So in such a way, you have to train the model, how the informations are being interpreted by the model. For that, you have to fine-tune some mathematical equations and parameter in order to make the model to understand your requirement and the disease well in advance. And with a few advanced early symptoms, the model has to find the severeness or new symptoms or a new disease. Such a way we have to build a model. How to do that? So now we were understanding that what is the heading is the what is deep learning is, how we are going to work on the deep learning in order to do the early detection of the diseases. So that's what the relevancy, how it is thinking, how it is interpreting the data, all that we have to work on with the mathematical equations to make the model to think very quickly. So whatever we discussed so far, the same way, they giving an input, and we have to train the model. That is the way it is thinking, how it is interconnectedly thinking, and all that. And later it is going to do the prediction. Here I have taken a few example of data information I have given. Okay, the input may be anything. As I told you in the previous slide, we were talking about the single symptom of the shoulder pain, but that is one kind of clinical data test. Sometimes your input may be from other type of input also. So for all that, whatever may be the input type is, whatever may be the source of information we are going to get regarding the disease, all that is going to act as an input. And that input we are going to feed it to the system for the system to understand and interlink and interpret the data, and it is going to predict it. So these are the basic steps, okay? So the same I'm representing here with the diagram. In an elaborated way, we were talking about the training and the prediction of output, right? The other steps are there. See why you want to go in depth of all this. In the beginning itself, I told you that there will be two kind of people working on the deep learning. One, those who want to develop a deep learning model which can survive or which can support for the medical field, building a model. Other may be simply using it. Other pre-trained models are there. It is being proven that those models are going to work well for these kind of diseases that can be used very well. But if you want to enhance the model, if you want to make the model to perform better, then we have to work on with other steps also. So the pre-processing, here it is talking about the data. It is another huge field. Whenever some clinical information is being given, we cannot take it as such. Some pre-processing activity has to be taken up, some cleaning of the data, or making it as a uniformity, or handling some noises. All that has to be done. And the next steps comes into the data splitting, because when I'm going to decide that this model is going to perform well, I had to prove that. In order to prove that, I may not be able to wait for a new input which is going to come in future. With the existing input itself, I had to evaluate the model that it is going to work with. So we are going to split existing information into the two parts, the training data as well as the testing data. For the training data, we'll be giving, here we are talking about this supervised learning. So the input and output will be given, the system is going to understand and all that, it is going to gain a knowledge. So in order to examine whether the system which is understanding or interpreting the data, it is going to be useful and it is going to predict my disease well in accurate manner. So for that, we may be using a testing data set. So here the testing data set will be passing only the input without showing the output. So the actual output and the predicted output can be evaluated. It can be compared and evaluated. So whatever you are training, that is going to be both the input and output. It is going to train, it is going to maintain a knowledge. For that knowledge, you are going to feed the testing data, which is consisting of only the input information. It is going to find, oh, these are all the symptoms, right? From this, for this symptom, this may be the disease. This is going to give you the outcome. That outcome can be compared with the actual outcome. So if it is going good for a multiple data testing data set, your model is good. So this step you have to work on. So here we are taking that, right? For a training also, the sampling of methods. See, for example, when I'm going to feed the system with disease symptoms, all the symptoms are not going to pass on to the disease. Some of the symptoms are going to give that this is not at all a disease-oriented symptom. So we have to pass on a data for both possibilities. So that is what the sample. When you are feeding the system with the information, we have to look into the all possible data. So that itself in another engineering process we have to see. Enough information we have to feed on to the system to understand and work on. So these models you can apply in many of the medical field. As I told you already that we have to find a model or build a new deep learning model for life-threatening thing, or it may be a rare disease. It may be to save a life of even a few set of people in the world. We have to build a model. So such a support we have to give it to that. So you can we can develop a model for any of the medical field like this. But as I told you already, all these medical field of prediction cannot depend on a single deep learning model. That is why there are variety of models, because the models learning and the training methodology varies. What are the different type of data available in the medical field? Whatever you know, please text it over in a chat. What are the different types of medical data you may know? MRI, medical image, clinical data, CT scan, OPG of teeth, CT scan, yes, X-ray, MRI, PET scan. Epidemiology data is mammograms, CT. Cancer is a disease. ECG, fundus image, stroke, EHR. These are all the parameters. Okay, medical data when you are going to report lab reports. Yes. Okay, now let us connect into the computer term. When we are talking about the data, either it may be a image oriented or it may be a clinical data like some numbers or a text, right? So your medical data, either it can be a structural data like this. So now we are getting into the more computer relevant terms also. Structural data. Many of you mentioned there is a EHR field of data like an age, lab, vital, ICD codes and all. All that are somewhat a structured information. We can pick what type of data it is, what range it may fall into that. Some may be a numerical data, some it may be a floating type data, that is an integer, whole number, or maybe a floating, or for all of that, we'll be knowing the range of value also. Because if the value goes beyond or lesser than that particular range, we can come into the conclusion that there is some disturbances in the value. So due to which the patient may get some disease, that is one of the symptom also. That is what that is a structural data is going to be. And the other thing is the temporal sequence data. Time series, the same vital information, we may have to maintain periodically. If it is an ECG, will be the continuous wave will be there. So that is all coming into the temporal sequence of data. How frequently it is happening, or that is in a uniform interval we have to observe it. The temporal random sequence is also applicable, but that is somewhat challenging. So the time series lab information, the cultural growth and all that we'll be observing, right? Whenever we are giving any kind of some sample testers, they'll be taking some duration, then periodically they'll be observing, and then periodically they'll be monitoring and recording the growth of that particular tissues. So all that will come under the temporal sequence of data. That is a medical data, that is a lab oriented, that also coming under the temporal sequence also. And the other one is a unstructured text, because sometimes I was saying you that, right? We are having, the patient is having this much of symptom. These are all the types of symptom. These are all the vital information, or it may be structural, temporal information, whatever it is. But for all that, what was the treatment given? What was the medication suggested by the doctor? Now only we are going with the digital formation of everything. But if I want to understand all that, the early structure, early information or suggestions or the treatment given by the doctor has to be taken as an value that you have to map it with the input clinical information and what the suggestion given by the doctor. Later on, when you are going for an explanatory AI, that is, which is going to develop in the place of doctor, it is going to write you the medication, it is going to generate the report. So in such case, the previous old reports I have to take and I have to feed it to the system also. So those kind of data are going to be that is also medical related, but it is an unstructured one. This are some of the sentences it may be a text format, it is a natural language format. And the next one comes into the images. So these are the different type of data we may need to handle in order to develop a deep learning model. That is in order to train the model. In order to train the model, these are the different type of data we have to handle in order to work on a disease prediction. And see to that, every time we may not come with the conclusion that this model is suitable for structured data. But some of the diseases have to deal with, that is, some of the diseases are going to have the information in a structural format or a temporal format also. So your model also have to work, or your model has to get developed in order to understand both the kind of data. So such a way we have to work on with it. There are some models exist in the field, then you can enhance that also to further. Some of the models, for like I told you, right, sometimes we have to work on the structural and unstructural also. So we have to train the model and we have to feed a model also with such a kind of input. And what are the challenges to go ahead with it? I'm having I know that I want to train a model. These are all the data I'm going to have, I'm going to work on. When I'm going to feed a data, I have to feed the system with the input that is a clinical data, or it may be a lab orient or image and all that, and the relevant output, how it was treated early, what was the disease identified for those kind of symptoms, all that I'm having. But apart from that, now I'm having the data. I'm going to train a model. I know that I have to train a model in such a way that the way in which it is understanding, in the way in which is relating the symptoms or the features what I'm going to give. So I have to work on with the mathematical equation on that hidden layer that I know now. Apart from that, what may be the challenge when I'm trying to implement this? Lack of dynamism. Diagnostic accuracy. Incomplete data, yes. Incomplete and insufficient data is a very big challenge in training a model, because when I'm going to give enough information, then only this model can understand. I'll be developing a model, I will be giving a very nice equations and a good mathematical working procedures internally for all that, for the system to learn and relate all that. But if I'm not giving enough information to the model, then how the model can gain a knowledge? The model cannot gain a knowledge. If I'm not giving a book for the student to read, then how the student will come out with the information that this is the way? I'm teaching the nicely that this is the method you have to learn. When you're reading, you have to take a notes. All that I'm feeding. When you are going to read, you have to recollect the previous concept, what you learned yesterday. All that I'm saying to them, but I'm not feeding them a book. So that is a one. That is a very big challenge in the medical field also. That is a lack and the insufficient data, unbalanced data. Because as I told you that when I'm going to give the data to the system, we have to give all possible data to them. If I'm going to give, for example, let us take, this is a one everyone can understand over here. So if I'm going to give one CT scan or a PET CT scan image for the system to understand and predict the cancer or the level of cancer also, then I have to feed the system with the all possible that. Let us take a one kind of cancer. Let me have it as a kind one. I'm not going to name any cancer type over here. Let me take a kind one cancer. That is on a one particular organ. Okay? So in such case, I have to feed lot of PET CTs of that particular organ region, the different levels also, because my model has to work and my model has to understand and it has to predict what is the affected level of that particular cancerous. This is the one I want to. Then if I'm going to identify that, then I can go for the early detection also. This is a level right now. What may be its future? How aggressively it may grow or it may not grow. All that I can work on with. So in such case, for that this particular region of cancer, for that I have to pass on variety of PET CT images with a different level, with a different nature of metathesis ratio in that particular region. We have to pass. So that we have to give on the all possible data. That is the one. And the quality of data is another matter. See, still the image processing and the image classification and the image handling in a computer field is still, it is under growing field. It is still, even after almost after 2 to 3 decades also, still we are working on with an image, because the image generation mechanism varies. The digital image generation methodology, the image generation technique are varying. So because of that, we in the computer science field also, we are working still on the different variety of images, because the image structure, the internal storage methodology, all that varies. Because of that, we also have to fine tune to handle those things. And in that case, if the quality of the image is a damage or a poor quality, which is not, I'm having a data, but even within that, I'm not having enough information. So in such case, that is another challenge. And as I told you, we are going to have a lack of samples also. So whatever may be all this, even with a few set of data, I want to build a model. What is the solution for that? I'm having an enough set of model. I want to make my system to work, understand those model very well, and it has to do the early prediction also. So for that, as I told you already, there are a lot of deep learning models, which are all going to have its own uniqueness, its own proven content. It is working on different field also. So whenever the deep learning model comes in mind, that is a CNN, convolution neural network. So it is going to, early it was started for an image. Now this is being applied for a non-image data also. So it is going to convolute. How it is going to start it? If I'm going to have the image set, it is going to work on with the region of images, and it is going to apply the filtering mechanism, and it is going to come out with the required amount of features alone. So it is going to convolute to the next level. So it is going to apply the filtering mechanism, and it is going to come out with the required amount of features. And based on that, it is going to finally classify it. So there are technical internal step, we'll call it as a pooling, convolution, like that. We'll be reducing the image and we'll be coming into the desired feature. Based on the desired feature, we can identify what type of image that we are going to classify that. So if it is of a medical image also, the region-wise sliding is going to happen. So if the required region, that is the required feature region will be filtered out, it is going to taken for the next step of process. So such a way the convolution model is going to work on. And the next comes the recurrent neural network. See, this particular one has been started for in order to work on with the numerical data. As I told you early, that is a CNN was started for an image one. Now we are going, we are using for another kind of vectors also. And the recurrent neural network, it is being started to work on with a numerical set of data. So it is going to match with your input as well as to the output, and it is going to reduce the gap between that. Initially, every input, whatever it is being learned, it is not going to come out with the exact output. Predicted output and the actual may have a different variations. The vast difference may occur over there. So it is going to work on to reduce the difference between that. In such a way, this particular learning method. So now you can connect all these learning method internally to the mathematical terms. So we have to adjust the equations which are all working internally. So for each of this model, the mathematical equation working behind this is going to play a vital role. And the next comes the auto-encoding model. It is also going to reduce the content what we have in your things. That is, it is going to compress your data. It is going to compress your data. I hope my screen is visible to you. That is my presentation screen.
Yes, ma'am, visible.
Yes, thank you.
This is visible.
Okay. So in case of the auto-encoder model, it is going to compress your data. It may be a numerical data or it may be image-oriented. After converting into the vectorization process, it is going to reduce your data size. It is going to learn on that and it is going to find an outcome. So how closely it is going to compress your data, that is the way it is going to work on. See, because when I'm going to have a huge set of data, I may not carry all the same set of information to all the level of learning. So for that, from this, it is going to reduce to the next level like that. It is not going to pick up the required feature. The entire information is going to be compressed and the required information is going to be taken up, and later it is going to connect it to the outcome. So this compression mechanism is going to play a vital role in this auto-encoder modeling. So that is from the original input to the compressed level, we call it as an encoding. From here, it is going to connect it to the output level, we call it as a decoding stage. And next comes the transformer model. So here comes the usage of handling the sequential data. As I told you, some periodical changes may happen. When one change is going to happen, we have to relate and remember the previous change also. So the sequential connected of tracking, we have to take it up, like the cultural growth or a tissue growth if I want to monitor over there, or the vital transmission for a periodical testing, or for all that, we'll be having a interval between for each reading. So I want to remember the previous one and the current one also. It is not only the immediate previous, sometimes we may need to remember a few past information also. So in that case, the transformer model is going to be the one. And the next comes that MAMO model. How it is going to work on this is going to deviate from the state-based model, we call it. It is going to be the another sequential model, but it is going to have the high efficiency and it is going to speed up the work. It is almost like a transformer model only, as I told you, that it is also going to work for the sequential data, but it can remember for a long sequential process, that too in a speedy manner, because when I'm going to recollect, if suppose I want to recollect the incident happened yesterday, I can easily quickly recollect also. If I want to recollect the incident happened a month before, I'll be taking some time, right? So that is also sequential information, but for the very fast information, I have to think a while and get it. So that gap, it is getting reduced. Because of that, the Mambo architecture is fast and efficient in predicting the long sequence also. This is also one of the transformer model, but it is. And the next comes the diffusion model. Actually, even in my teaching also, I'll always be saying to the students that, especially in learning a programming language, I say them that make a mistake and learn. Do the error and learn. This is also such a kind of learning it is. Actually, it is going to create a noise in a data. My original data is there. My information is going to be correct. I'm having it correct, or it may be a disease one or a non-disease one it is. So whatever the input I'm going to pass on to that, it is going to create a noise in the data. It is going to create a noise. So it is not entirely, it is going to randomly create a noise. So from that, it is going to regenerate, and it is going to clear the noise one by one. And from that, it is going to learn. So if this is a noise, this is a non-natural, or the one what I'm going to feed. It is apart from the one what I'm going to feed. It is going to create another additional information over there. We call it as a noise in this case. So it is going to have a noise on the random location, and it is going to work on the data line by line. And if it is a noise, so this kind of error may come. So if it is the case, what it may be, early what it was, from the noise, it is going to pick up the original. The original data is there. Original data is there. In that place, in the place of original, it is replacing the noise. So by clearing that, it is going to replace the original data. So in such a way, it is going to learn it. Noise creating, and it is going to regenerate the original data from there. So that is called as a diffusion model. This is also useful for for example, if you want to develop any of the molecular generation one, or any of the application, like even if I'm going to connect here the slide as an audio generation. That is because of the sequential one, right? The continuous wave we may be working on with. So such a kind of things we can work on. So this is a noise. But what may be the previous, what may be its original. So by doing so, it is going to learn that such a kind of model is a diffusion model it is. And the next comes the graph neural network model. It is, as I told you, always it is going to be of interconnecting. It is not being connected with the one immediate or one piece like that. As it is a graph, we have to have a network of connection also. So for those kind of multi-connected information, then we can go for this graph-based neural network model. And the next comes, we all aware that is a BERT. It is applicable for a large language development. It is a bidirectional one and all that. So if I want to work on with the unstructured clinical data, if I'm having a doctor's report, clinical report like that, if I want to understand and work on that, we can go on with any of these BERT model. So likewise, based on the purpose, based on the learning methodology, based on the input data, we can work on with these models. Whatever I'm displaying over here, whatever I have listed over here, all that are basic models only. In every category and every requirement. There are some of the enhanced models of this exist in the field. From there also you can enhance further. As I told you, there are a lot of enhancement happening in the existing models. Based on that, many more advancements are happening in the field. It is for a prediction, well in advance, early prediction also, and the accuracy level is getting increased. And in the many places, we are combining the models. I can give you the example in the previous that if I want to have the sequential data like ECG report I'm having. So apart from that, I want to connect it with some clinical notes. So then I can combine these hybrid models in whatever the way we can combine it. That as an expert, you have to work on an experiment. So on the whole, we are going to work on with two different data in your image process. That is your clinical data. Either it may be of image, either it may be X-ray image. You are saying CT scan, MRI, and PET-CT, and all that. X-ray, all that coming into the image format. The other one, if you are going to talk about the EEG or EHR, the vital, and all that, it's the clinical data. It is going to be a numerical or somewhat it may be a text also. So now in the further discussion, I'm going to connect two different models. One is to work on a clinical data. Other one is to work on a image. Okay. So the first one is that is a temporal convolution network. That is the name of the model. I'm going to here detail you how this model is working with in order to handle a sequential clinical data. So if I'm having a different vital temperature, that is my BP sugar level or a diabetic level, that is a diabetic level, my BP range, the different times duration of BP, if I'm having such a clinical data in my hand. So based on that, if I want to do any prediction, then we can go on with this temporal convolution network. Clinical data, and also that the clinical data in a periodical sequence. So this particular is alternative for this RNN LSTM. As I told you that the RNN was the one which was being built to work on with some numerical information. And apart from that, now this TCN is going to combine with the time series data. For example, it may not be for a 1 day or a 1 hour of data or every 1 minute like that. It may be a long duration of that is every 1 year once. Last year, how it was. This year, how it is. So likewise, some periodical clinical information if you are having in your hand, that period duration may anything. It may be of 1 hour once, 2 hour once, or 1 year once, like that it may be. So in such case, it is maybe a time series data one. In such case, the TCN is going to be applicable. This is another enhancement of RNN model. So when it is coming to the TCN, broadly it is going to work on two technical levels, that is a casual convolution and the dilated convolution. I hope you remember what is what was the convolution I said, right? If I'm having here once again drawing an image, but the same is applicable to the numerical also. I tell you how it is. So if I'm having an image, I'm going to apply a filter over there. The filter is going to slide on this image on a grid basis. And we are going to apply the pooling mechanism, and it is going to be the next level of image, which is going to come out with only the required feature and extracted area. This is called as a convolution. So how this convolution is going to work on this TCN is, if I'm having today's data, for example, day 1, day 2, day 3, like that, I'm having a day-wise information. So the day 1, I'm having some reading that it is 10. Day 2, I'm having a reading, it is 12. So when I'm reading and when the system is trying to read and understand the day 2, it is going to relate the information onto the immediate previous one. That is information leak from the future. It is the time t dependent, immediate time t, that is the previous. If I'm working on the t plus 1 time, it is going to have a relation with the time t data only. So that is the casual convolution. So by doing this relationship, it is going to come out with the next reduced required feature alone. This is one thing. And instead of that casual convolution, the other convolution that PDL is dilated convolution. So here we can change the periodical. It may be because of the when I'm going to have an exponential growth of any particular tissue. So in such case, we may not, or it is not required always to connect with the previous stage of that particular tissue, or if it is a cancer one, if it is a metathesis ratio, if it is aggressively growing nature, if it is. So in such case, it is nowhere it is being required to compare with the immediate previous growth. So it may be the exponential process. So I can have some periodical gap. For example, if it is of a 1, 2, 3, 4 like that, even if I'm going to take these 3 data in order to study, when I'm going to reduce it, I can have a 1 gap of interval. The 1, 3 can be combined, 2, 4 can be combined like that. I can change this interval also in a different way. That is what a dilated convolution. So based on this method, we have to change some parameters and equation in your model development. So these are the 2 basic level in this TCN, that is internal working procedure in a convolution process. So now we come into the exact working procedure of this TCN. When I'm going to feed a data, it is a numerical clinical data at BP. So when I'm going to feed it to that, initially we are talking about the 1D. So assume that one set of clinical information I'm having. For example, a continuous reading of BP or continuous reading of ECG. That is 1 dimension. The same you can expand it for a 2 or 3 dimension also. For example, when I'm reading a ECG report, ECG for every 10 seconds once, let it be, or it may be every 15 seconds once, I'm taking my ECG rate, I'm recording it. So at every moment, I want to record some pumping ratio, or it may be the other relevant information along with that. So this is a dimension 1. In a second dimension, we'll be including other clinical information also. It may be a BP, or it may be I'm taking that as a oxygen rate in my blood, whatever it is. So likewise, if I'm going to increase the number of input values, then the dimension is going to increase. But for all the dimension, if we are going to use a dilated one, so the same periodical we'll be using. If it is a dilation is 2, so it is going to skip 1 data in between for everything. That is for a BP also, it is going to skip 1 data. For oxygen rate also, it is going to 1. Even you can go for a dilated 3 also. It is going to skip 2 data in between. So 1 and 4 will be taken, 2 and 5 will be taken. Like that, it is going to take a periodical. The 1, 2, what I'm saying is a time. That is a time moment at which we are recording the readings. So likewise, the 1 dimension can be taken into the n dimension also. When I'm going to pass different possible input parameters, input clinical data to the model. So first it is going to do the long-term learning, but by the dilated one. So if I'm going to give us a sequence of data like this, so it is going, if it is a that is a two-step dilated one, it is going to reduce the value like this. So in the initial first step, if I'm going to have a 4 input, that is a 4 sequential reading data, for a second next iteration, we'll be having a 3 sequential reading data. So how it is getting reduced? For all that, we'll be applying some weightage factors, some calculations we are going to work on with that. And so once after coming out with like this to the reduction, and the final output, we have to compare it with the actual one. Based on that comparativity, the residual is going to work. In the case of the residual, it is going to connect with the input and back to the output also. How it is going to connect with your input and output, how far your actual output is varying, and how it is going to relate to the input level. So based on this weighting factor are going to be adjusted, it is going to learn further. So in such a way, it is going to do that. So how many level of reduction we are going to work on with? So that you are going to decide based on the layers. And how you are going to relate one input to the other, that is how you are going to interconnect some of the input parameters with the other input parameter. Based on that, we can increase the node within a numerical, that is a natural, within what your ANN model, that is in between you are having a neural network, right? In that you can connect with the nodes, how the weighting factor is going to be. And see here, this weightage factor also one of the other key mechanism which is going to decide your model performance. But initially, we may be picking it in a random way. This is another engineering technology. When I was discussing about the entire flow of data processing, that is your deep learning model, I told you that the pre-processing is one of the engineering and the data picking is one of the engineering. Like that, this weightage identification is another engineering process it is. So whether we are going to take it as an accurate or closely relevant to that, that is this mathematical equation, that is a parameter or some constant value, what you are fixing for your mathematical equations, that it is another engineering task where you can work on with and how to identify the accurate and very close to the one in the initial itself. So this is the way the TZN is going to work. Let me show you this in a diagrammatical way. We can move from the bottom to the top. See here, as I told you, in the first shot, whether I'm going to work on with, as I told you that it is an enhance of LSTM, right? Long short term, that is a LSTM. It is always going to relate the data with the previous also. So how many previous sequences it is going to handle together, that is also matter. So here it is going to, as per this diagram, it is taking 4 immediate sequences together. From there, how much it is going to dilate, that is the next step. That is the dilation is the uniqueness of the TCN model, that is your temporal convolution network model. Even in that, how many continuous sequence it is going to handle at a time. That is another task, that is the LSTM model. That is why the TCN we are talking about the enhance of LSTM1. So in that case, so once after reading the first few sequences, it is going to be a sliding window it is. So after which it is going to take the next set of sequence like this. It is going to slide for a same pattern of sequence also. If we are fixing that the LSTM learning sequence is going to be for a 4 sequences. So for this entire learning process, it is going to take 4 sequences continuously for every step. So whatever the sequence it is taking, it is going to apply the dilated, but whichever the convolution we are going to, whether the casual convolution or dilated, based on that, it is going to reduce to the next level. So likewise, it is going to have an encoding. I think you remember that auto-encoder mechanism. I told you that it is going to compress your data to the reduced level. So now this compressed level is only the required amount of information, what is relevant to your identification, that is your disease prediction, and that has to be connected with the output. And we cannot say that this particular prediction or the feature extracted or the filtered data or encoded data is sufficient for the output. So in such case, if there is any that is a wrong deviation, then there comes the residual process. It is going to connect this to the input. So what adjustment it has to do go along with that. So that is where it comes into the back propagation. And also that we are talking about the LSTM, right? And that is the continuous sequence of data to be connected or taken for the process. So in that case, the relevancy of these two information or these two information it is going to maintain. Even when it is moving on to the next sliding window, the information gathered from the previous sliding has to be maintained. There comes the concept that is the gradient. It is, we are not supposed to leave the data to get vanished. That is, we are not supposed to forget the data. We have to remember it. So how long we have to take it further? So accordingly, we have to make use of the necessary gates over here to remember the data also. So whatever I have given you, that is a term that the sliding process, the remembering on the gate, or if it is a residual, in all these places, you can have your computer science enhancement to make this model better. When you are going to touch on in any of these places, accordingly, your model performance is going to vary. Model performance is not only in terms of accuracy, the time taken to work on that, how quickly it is going to respond for all that. In any of these places, these are not existing model we are talking about. Even an existing model, as I told you already, if you want to enhance, if you want to change the model according to your requirement, you can work on this, any of this particular stages of this learning model. You can come out with a new other or enhanced or refined model according to your requirement, because the way you are fixing the model for one set of data will not work for other set of data. So this is the way the TZN works. All the basic deep learning models we touched, we had discussed with the one line of definition, right? All that it is getting connected over here. The next comes another model, that is a vision transformer model. This is to work on with the image. In the beginning, we had discussed that the different type of medical data. On the whole, once again, it's either going to be a clinical data, that is a numerical data, or a sequential data like that, or it can be a image. So this is in another model. This is a reason enhanced model. This is the next variation of the CNN, the most variation of the CNN. It is a vision transformer model. It is to work on with the image. How it is going to work or interconnect the images. That is what this particular uniqueness over here. So whenever, as I told you that, the remembering the previous one, the interconnecting with the previous incident, or reconnecting or interlinking the information is highly important. The same way this model is also going to work on with. So it is going to work on with a large global relationship across the entire image. Every part of the image has to be connected, or it is going to be related with the other. See, from my understanding or from the clinical one, I'm saying you that sometimes if the symptom occurs over there, if I'm going to take a one X-ray of or a PET CT or whatever for a cancer image, cancer treatment, I'm saying you that if I'm going to take a PET CT one, when I'm going to when this is being taken up, the region which the part of that particular one is getting affected, same way the other part may affect her, or it may be the relevant. or even if you are going to feed two different images of two different organs, that is what the PET-CT now is, right? It is going to take the entire body of, it is going to take the scan on entire body to identify the metathesis ratio, which is occurring in any other part of without a symptoms also. So in such case, when you are going to have a comparison, one part of the image has to be compared with the other part in order to get to know that how equally or unequally these two tissues are getting affected. So that relevancy can be maintained because all the places are not going to be treated equally. Based on the affected nature, the treatment may vary. So in such case, if I want to interlink the portion of information which is getting affected, or how the similarity or difference of this particular region can be connected over here. So in such a way, this VIT going to work. That is a vision transformer model is going to work. It is going to maintain a global relationship and understanding with the other part of the images also. That is the uniqueness of this. So for that, how it is going to work, how it is going to maintain a relationship or the understanding or the connectivity of one part of the image to the other part of the image. So for which first step it is going to work on with the patch embedding or splitting of the images. It is going to, entire image is going to be divided into different chunks. That is called as a patch. That is based on the height and width of your images, how far your size is, height divided by this much. So that much number of patches you will be getting on it. So all that we are going to form it as a matrix. And now there is a large portion of encoding model patches, that is you are going to tokenize it, because the patch 1 has to be connected with the patch 2, or it may be a patch 10 also. So the class token, it is going to applicable. There is a special token, it is going to apply to sequentialize those patches. Because once after connecting the one patch of image to the other patch of image, it is not to the immediate next patch. It may be to the other patch also. So after that, I want to make it as a proper order also. So in order to do that, first it is going to allocate a class tokens for that in order to globally sequentialize or to represent the image patches. And afterwards, it is going to apply the parallel understanding or learning methodology of each of the patches. And at last, it is going to, based on the token, it is going to rearrange this. Let me show you the image, that is a working procedure of this in a diagrammatical way. See here, the entire image is getting taken into the different patches. See to that, though the image is in a matrix format, for a learning process, we have to make it as a linear vector. It is linear vector in the sense each value is another image part only. This is what we call as a patch. This portion is called as a patch. So that is why, based on the height and width of the image, the number of patches may vary. And now those patches are being taken into the linear projection, and the patch positioning and embedding, the tokenization, the sequential mechanism, it is going to take in. And now it is going to understand and learn the relevancy of the images. The one it is going to take in a parallel. See here, this learning process is going to take in parallel for each of the position. After that, the interrelevancy information are going to be interpreted. It is being taken. That is what the it is perception. How it is going to multi-learning perception. It is going to take it out. So this is the way it is going to work on with the different patches of images. So because of this, the patch 1 here in this linear projection, and after that in the patch positioning and embedding in this learning stage. In this stage, the patch 1, it is getting connected with all the other patches wherever it is required, but it does not mean that all possibility you have to try out with. It is not the patch 1 has to connect with all the n-1 number of patches. It is not like that. You can decide on it. So in such a way, you can variate this model also. But the basic learning methodology is From each patch, it is going to take an information, and the one patch of information is being related or compared, or similarity is being identified by one patch to the other patch also. That information is going to maintain over here. So in this way, that is a VIT is going to work. The vision transformer classifier, once again, it is for an image. Instead of taking every part of image and scanning and taking the feature, it is going to relate one set of one portion of the image to the other portion. So all the portions are being taken at the whole. It is going to parallelly process the patches, and at the same time, it is going to interlink from one patch to the other also. So on the whole, we have connected with two different dimensions of the medical data. One is all about your clinical data, where we are dealing with the numbers, and even if it is a text, if you that is unstructured information, you can apply some of the BERT model and you can make it as a text. So that is a numerical format, and that also you can connect with. So for which we can make use of the TCN model. So you can work on with the clinical sequential time series data. The other way, that if you are working on with an image, apart from the convolution model of images, you can work on with the VIT model. So from here, where we can go further. That is what your future direction. So say how this can be I applied or used for early detection is the way in which you are fine-tuning the model, and how you are enhancing the model to do the learning. So if it is coming to the sequential model, why I have taken the sequential model here is that for early detection only. So if the previous from the previous history, what you can understand that, for example, if my BP for this particular duration is going like this, in future also it may go like this. So from the early few set of BP rate, you can able to predict the future well in advance. I'm very small example I'm saying over here. The same way you can apply for the other disease also, but see to that, as I have given you the input, we are not supposed to stop with the one dimension of data. Every disease is not going to stop with one symptom. It may connect with all other symptoms also. Always my suggestion is here is whenever we are developing any model, getting an approval from the authority is highly important. That is, if you are working, if you are developing a model exclusively for the medical field, the approval from the medical authority is highly important before taking it to the world. That is the one ethic we have to follow always. Okay, so when you are going to work on well, you can make the model to work well in advance, that by giving all possible input, and at the same time fine-tuning the model, that the crisp limited information, it has to identify the future also in better way. That is for especially in the sequential data. If the continuous growth is like this, here you don't need to go for every continuous growth. That is what the dilate comes into the picture in a TCM. So accordingly, you can work on based on the parameter, that is the feature what you are going to feed into that. That is your input value. So based on that, we can pick a model and work on that, and go with the enough number of experiments for this. We were talking about the different levels, right? So here we were talking about the different levels of work in every model. So for every kind of, every level of this particular model, you give your experiment and come to the conclusion and come to the final. If I'm going to increase the sequence, how it is going to be. For all that, see, for all this, you can get an open source, the data that is from the documentation section, from the TensorFlow site, pie chart site, wherever you are working on with. You understand which particular parameter is going to change each level of working procedure. Or else, for example, if you want to build a different residual methodology, you develop the residual methodology, how this particular input and output is getting connected, and you can work on them. So likewise, for every part of the learning stages, that is a internal working step of this particular learning model, you can give your input. So in such a way, you can build and enhance new models also. So I'm stopping my delivery of information here. of the participants, if you are having any doubts, please raise.
Participants, if you are having any doubts or need clarifications, you can ask now. Unmute yourself and can ask.
Ma'am,
Yes.
may I know what is the maximum number of data used for deep learning, ma'am?
It is not a maximum. That is what you have to give enough possible combinations. For example, if I'm going to take it is of a diabetic, let me take that one. So in such case, if you are going to go for a diabetic one, in order to identify all possible symptoms, you have to feed in. That is what, instead of going with a random sampling, you can fix the all possible inputs. For a diabetic, yes or no, this is one kind. Even if it is an yes, what are the, because even if it is a diabetic patient one, there are different types of symptoms and parameters will be there. It will be case to case, it may vary. So you have to give all possibilities. It is not one this much. Even with the 10 data you can train. I'm saying you the sample. Even with 1,000 data, if you are training it, if that apart from the 1,000 data, if there is any possible other cases may occur. So definitely in that case, you have to increase the volume of data also.
Thank you, ma'am.
Yes.
Participants, if you have any doubts, you can unmute and ask. You can also message in the chat.
Madam,
Yes.
what are the practices or procedures we need to follow for pre-processing this kind of specifically medical data?
For students, you are asking, huh?
For research purpose.
Ma'am, for a research purpose, that is what first you can always we say that no, if you are going to go with the application oriented, then you can decide on which particular disease you are going to work on with, and you have to study what are the other existing solutions for that. And what is the lagging behind that, whether the model performance in accuracy wise it is lagging, or it is lagging in terms of the performance, like the speed, the time it is taking to train and all that. So after that, you can take the existing one enhanced model already, which is coming out with a high accuracy. From there, you can identify where it is lagging in. So because of the residual, whether it is lagging, then there it comes to the research component. So the previous one is the review and understanding how the existing models are working. Even with an existing model, what is the what kind of solution are still pending to the society. So in such case, that you have to identify. By focusing on those particular part you are going to work on. So in order to fulfill that particular requirement, in what way you can enhance the model in any of these internal procedures. It is not going to be apply the working on that, fine-tuning the parameters like that. So as a novelty you have to prove, then we have to work on this, any of this learning procedures internally. In such a way, you can gradually take this input to your research scholars. Make them to understand in which particular medical field the requirement is, what existing are there, what existing model is giving a solution right now, where it is lagging, because of what internal procedure that particular model is lagging. In such a way, we can take it further.
Thank you, ma'am. Thank you. Participants, any more questions?
Good evening, ma'am.
Yes, ma'am. Good evening, ma'am.
Ma'am, that early detection normally leads to false positives. Is there any specific deep learning model for overcoming that?
Ma'am, it is not like that. Actually, false positive, false negative, and all that based on the model learning procedure. So, which part of the, as I told you already, which part of the learning procedure you have to fine tune in order to reduce that. Actually, in one research I too worked that we are not supposed to leave the patient who got affected without PT. At the same time, nowadays in the medical field, the other form is also required that unnecessarily we are not supposed to give a medicine to any patient also. It is not focused that always we have to work on that false negative. False positive also we have to focus.
Okay, ma'am. Thank you. ma'am.
Unnecessary medication is also not advisable, no.
Yes, ma'am.
So we have to work on with to reduce both of that, ma'am.
Okay, ma'am. Thank you, ma'am.
Ma'am, any popular repository for healthcare data set to implement deep learning, ma'am?
Ma'am, we cannot say it is a popular repository. We always go with all possible. That is what I have to say. For example, we have to give enough data. We are not supposed to depend on one repository to pick it up. We always go with the UPA. Nowadays, the Kaggle is also giving, and GitHub is also giving. We are having a lot of image data set from the IEEE data. The Google data is there, and nowadays. The AI Medical Mission of India, that they are also having a lot of one. So likewise, we can take information from multiple sources and we have to work on, ma'am. Even I too noticed in many of the research paper that working on a particular one data set, that is not advisable also. For an experiment purpose, you can pick, ma'am. The UPA you can pick, or from IEEE data you can pick it up. One thing you can work. But if you are going to come out with model, and if you want to prove that your model is working on with, you can pick it from a different repository, and we can work on with, and we can do the experiment on the different data sets too.
Thank you, ma'am.
And one more advice here, I want to give it here that whatever the repository you're going on with, something might be an augmented, some may be authenticated after evaluating the repository is allowing the data set. But in some kind, many will be uploading and they are loading the data. We are working on that. We may not know whether that is a real medical data, it is an augmented one also. So for that, my advice is always, as I told you already, whatever the model you are developing for a medical field, getting a approval for that accuracy from the doctor is highly important. The same way, try to get a real clinical data and work on that. At least a few samples by producing your ethical documents, that the disclaimers properly, you can get a real data and work on that, at least to the testing levels.
One question was there in the chat box. Any specific AI tool to analyze medical data set?
Actually, you are going to have one more session in this specific pre-built no-code tool. The other resource person is going to take. You are going to get a knowledge in that. Say many cloud one it is you are going to have. That is what we are having a pre-build. In what way you are taking it as an AI tool to analyze it. Once again, AI tool is going to work on with any of this model only on the background. Because the AI, it is going to give you the automatic outcome. Analysis of medical data itself, you want to take it as an AI. That is what the low-code machine learning one, the other resource person is going to take. You are going to get a lot of information in that. So in such a way, we can have it that as an AI model for a medical analysis.
Thank you, madam. Pushpa, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you for your insightful presentation on deep learning models for detecting early disease. Your expertise and vision made us to know how AI can truly transform the healthcare. Thank you so much, ma'am.
Thank you all. Thank you for the opportunity. Thank you all the participants for listening so far. Thank you so much.
Thank you, Gokila. Thank you so much.
Now I request Dr. Vijay Kumar to introduce Dr. G. Suganya Madam, Professor and Associate Dean Scope, VIT Chennai, for the session on AI image analysis, teachable machine and Athon.
Good evening to one and all present here. It's my privilege to introduce our another chief guest today. Dr. G. Suganya is a distinguished academician and researcher with over 2 decades of experience in computer science and engineering. Currently, she is serving as an associate professor, senior, and deputy director of the software development cell at Vellore Institute of Technology, Chennai. She has established herself a prominent figure in machine learning, software engineering, and applied AI research. Her multi-faced career encompasses extensive teaching, prolific research output, successful industry collaboration, and significant contribution to institutional development. She has completed her PhD in software engineering at Anna University, Chennai, ME in software engineering at Anna University, BE in computer science and engineering at Bharathidasan University, NASCOM certified associate analytics trainer. Her areas of expertise are machine learning and deep learning, software engineering, theory of computation and compiler design, programming language extension. Actually, Madam has over 20 years of distinguished experience in teaching and administration across various engineering institutions with active membership in ACM and ISTE Life member. Dr. Suganya has an impressive publication record with 30 plus research papers in prestigious international journals and conferences, including Springer, IEEE, and specialist journals. Her research spans COVID-19 detection and pandemic management systems, and disease prediction, IoT-based solution for healthcare and automation, machine learning application in agriculture and sports analytics, deep learning methodologies for crop models. Actually, Madam holds a published Indian patent for AI-based dietary needs management system in 2020. She has successfully completed multiple consultancy projects at Mahindra Research Valley, AR-based car owner manual development at Firmwise AI Private Limited, shape and polygon matching and agricultural application. This is in multiple phases at FL Smith Private Limited, AI-based recipe identification tool for rubber industry. This is an ongoing research project. Then, Madam published 2 textbooks. One is Compiler Design in 2007 and Theory of Computation in 2009. She deployed institutional software systems, including event management and corporate training portals. Madam is currently guiding 3 PhD scholars. She delivered 90 plus lectures and webinars. She also organized numerous workshops, seminars, and conferences. We have such an eminent persons today. Now, on behalf of our team, I welcome Madam to give her lecture. Thanks, one and all.
Thank you, sir. Now I request Dr. Suganya to take over the session.
Yeah. Thank you, Dr. Vijay Kumar and Dr. Shoshita for the welcome. And am I audible? And is my screen visible?
Yes, ma'am, your screen is visible and you're audible.
Okay. So, Very great evening to all the learned people gathered over here. So I hope there are more than near to 200 participants who have gathered here. It shows the impact of AI. That's what I would like to place on record. So everywhere when we talk about AI, the impact is becoming more and more that every one of us would like to understand what is the impact that it will bring in to us, first of all. Let us be a researcher, let us be an academician being in a teaching position, or be a researcher at our working stage, or there are PhD scholars. I hope they are part of this group, whatever it is, right? So when we talk about AI, so it is such a buzzword that it is placing or it is creating such a numerous change to this particular scenario. So I was watching to the previous lecture. So madam has given a very wonderful and very insightful thought process about what and healthcare is and what are the different models that has evolved out of the scope, okay, from in the past few years, let's say around 10 years of down the line, and in this particular medtech scenario. And one thing we have to understand is that all those are what are the technologies that are brought in place which can be applied to very different or many different health, there is what you call application domains where you are working. And since the FDP is clearly focused on medtech, let us try to understand what are the different ways and means, right? So in this 1.5 hours, since I hope in the past 1.5 hours, you have a very great knowledgeable session on the various recent models that are there. And she was explaining clearly about the flow process that you have to take care to coming up with the decision making and all those stuff. After listening to that, I just try to make the session in a different perspective, trying to make it in a very simpler way, because the previous session was wonderful for an already improvised and then people, there is a group of people who are already having a knowledge on this. So let me try to give my own perception of how we can make use of this AI when it is not an actual word that has been brought into the public now. So AI is there existing from 1970s, 80s onwards, but unknowingly we were using it for different terms. So we may calling that as a rule-based scenario, or then we were talking about fuzzy logic, we were talking about genetic algorithm, which has its footsteps from 1980 onwards. All those are now become coined, and those were put into one particular basket, and that's where we call it as AI is all about. Looking into the impact of AI into this healthcare industry. Okay, so so we need to completely understand what is the significance of using it in the medtech. That is very, very important. So without having a clear idea of why are we actually posing a technology to be used into an industry or used into a particular sector or a domain, so it will not add value to our work. Second thing is, why do we consider it as more important to make use of this AI technology into this medtech environment? So this diagram which I'm showing you now may clearly give you a guess of where the world is currently moving towards. And this is not what actually is, what are we going to get in the next 10 or 15 years. This is what is currently existing. And we are going to discuss in detail about what this robot is actually doing. Are we safe in the hands of this robot? In such a case, as a researcher or as an academician, how can we get involved or how can we think ourselves into the line of context to better understand how do we align our research area into this medtech context? So that is what I think I can give you an overview about. So looking at these pictures now, okay, so my presentation is completely figurative, and let us try to understand what are we trying to convey by that sense, okay. Now, if you see this, looking at AI, always we say this artificial intelligence or any of these intelligent technologies are there existing only to support the human beings, not as a replaceable one. So in that case, if you look at this particular picture, okay, and the one which I'm showing you now, okay, so this robot should not completely replace this human being, rather it should give a hand to comfortably make the human being work on the risky or a most important or a critical life point of the human being. We may have a question of, right? So what happens when the robots were not there? And why do we actually get into this kind of robotic things? Earlier, if you think some 10 years behind the screen or before COVID also, the number of healthcare issues were not this much. And it has grown exponentially to an extent that people are not able to stay in an hospital now since because of the overcrowd and because of the unavailability of the beds. That is what is happening. And due to our metabolism, lifestyle change, and so many other parameters, which we do not want to make it a point here, the number of diseases that are actually being diagnosed in the human beings is getting more and more. Okay. In such cases, the first one is the unavailability of the human being, or the trained or the experienced human being is what matters. If you compare the number of medical colleges that were existing 10 years before and now, there was a slight increase, but not up to the scale of how much the human being present population is actually in need of. That is one thing. The other point is that when the number of doctors who are coming out of the medical colleges are getting increased in a slight pace from the 2015 or 14 onwards, if you look into the history back, what about the experience that they are gaining? Okay, so moreover, they are all working for only 1 decade, and that too, they will be spending most of their time looking for their higher education and other apps. So what about the experience? So the lack of the experienced faculty makes us to move towards any sustainable technology that can help people, not just replacing the doctors, but by helping them to arrive at a particular or more specific solution point of view. So that is where these robots have to be considered as a very important factor. So what is this robot? Okay, when we talk about robots, so there is so many misconceptions that are there. So should the robot be only in the form of a human being? That is one major question that everybody has. Okay, need not always to be. This is what we call as humanoid robot, but a robot is one which can operate by itself without too much human intervention. That's it. It can either be a complete software unit, or it can be integrated into any hardware units which can operate off its own. That is what we mean to call by robot. And looking at what left picture, what this doctor is doing. Okay, you can see, you assume that whatever is covered in this particular place, it's a human being, and there is a machine that is kept on top of the body of a human being. Right? So, and this is the context on which we have to correlate what are we actually doing to help the doctors or the nurses. What this doctor is doing, he is actually having some kind of medical device at his hand, trying to make this particular robot do the surgery. So, we may have a question of, instead of doing something on this machine, why do the doctor operate to get it set? Okay, I'll give a very simple example. Now, we visited recently one healthcare division or one healthcare company where they are actually producing a robo. What is a robo? The robo is not generally in the form of a humanoid robot. It was actually a machine that are fitted with a monitor. Okay, so this is one real-time scenario which I would like to tell you to pick up on what are the different areas are available to you to pick up your research areas context. Now, what are they doing? Let's say if there is a nodule that is there existing in any part of our body, if we want to break that nodule into pieces, okay, so what the doctor will do, they will make us lie on the bed, give some anesthesia, and all the preparatory works will be over. And our anesthesia will either be local or complete depending on the seriousness of the issue. Now, in whatever sense, be it local or be it complete, when it is given, okay, so the body will go to a peaceful, silent node. That is what is the assumption. Now comes the usage of the machine. Now, what the doctor has to do, he has to find out. You will normally know, let's say the nodule is in the chest. So the doctor would have taken the chest X-ray And if in detail it is required, he may go for chest X-ray, chest CT. And then if that is not also enough, they may go for chest MRI. And all these things they will diagnose. And he has to understand what is the current X and Y position in which the nodule is actually present. Because you see, every one of you can understand the fact that not the bed which is lying where the patient is lying is actually having the CT or the X-ray machine or anything of that kind is fitted with. So the images are kept separate and the patient is there separately lying on the bed. With all of the experience that the doctor holds, he understands that the problem might be lying on a particular area. So might be lying, okay? The point is very, very important. The size of the module matters now, okay? If the size of the module is a little large, that's okay. If you want to pierce your needle to break it down into pieces, it's fine if you can go pierce it in the next 1 centimeter or 2 centimeter ahead. But what if the size of the nodule is very small and the nodule is actually being surrounded by a lot of nerves, which are very important and intact. So for us to keep the patient alive. So that's where the problem comes, right? So with all these intentions, even an experienced doctor, they may feel very, very difficult to get into the patient. I understand where exactly the point is, keep the needle there, drill it down to break it into very, very big pieces. So you understand, all our human beings are there with different kinds of emotions. When we are coming from a very long distance, when we have a lot of patients, okay, and when depending on a health condition, many biases are there in the the operational procedures. Now, how can this robot help? Okay, so that company is actually producing one kind of robots which actually does this process, right? When you feed that particular robot with the image of the CT scan, MRI and all those stuff, it scans the body. What does the scan means? It takes a picture of the entire body which is lying on the bed, okay, surgery bed, okay, and it locates what is the shoulder position. From there, it calculates how many inches does the robotic hand has to move, and then where and all the piercing has to happen. Okay, now you see this particular minute particular case cannot even be thought of by a human being without a particular case. And you see, so after having positioned that particular pinch of needle, okay, in the correct position, it gives an alarm to the doctor, and the doctor can now go pierce and then break it into pieces. Now, again, the doctor only is doing the surgery. It's not what a robot is doing a surgery, but what the robot does, it actually helps the people. You may have a question of then, instead of this being given back to the doctor, why can't the robot itself pierce the needle? Yes, it can. But the fact that always a human being will be preferred by a patient rather than by anybody is what makes the last final touch, okay, and brings in the necessity of always a human intervention. And that's what make you and me live in all these cases. So that is what actually exactly is what the doctor is doing. He is trying to send in the signals from this device. Okay, so for a presentation purpose, I tried to take a picture from a free repository and we couldn't able to do that. But this kind of box will definitely be a monitor. And many different that is what advantages you can see. One thing is, when the chest X-ray is actually being given or chest CT is given to the robotic machine, and when you fix in the portions where the nervous system actually happens, it creates a segment. Segment is what? It actually creates a borderline stating these are the positions where the nervous system is actually there. When, let's say, okay, so then a question comes. What if even if the body is in anesthesia, we will have the breathing that will be there. Due to the breathing, there may be a slight difference in the body alignment. Now, what if the body slightly moves? Okay, and exactly the measurement of that XY position, when it gives the needle in a place, instead of a nodule, when it tries to bring it back to our nervous system, what will happen again? Now comes the robotic process. Okay, what it does, since you already have marked in where and all the nervous system is there, when the needle is actually pointing to that, it creates an alarm stating that, asking the doctor to stop and to realign the position. Now you see the comfort, it's not only the comfort of the doctor, it's a life-saving procedure that what we are actually experiencing, right? So what are the research provisions that are available? Okay, so I have narrated a scenario where an actual robotic, robot is actually helping a doctor or a nurse to do a surgery. But as a researcher, what is that are we going to get out of it? How can we give back to the community in one way or other? Okay, or let's say to end up with at least to complete my PhD, or since my area of interest is on that, how do I move ahead? Okay, now you see there are a lot of avenues in which we can think of. One thing is, when a CT is given, right? The CT need not always to be in a very high, very clarified manner, right? So the image may need to be improvised to a greater extent. So making it, let's say, in the background of our video, when we join the Zoom call, there are provisions to make it blur or add up a background image and all those stuff, right? Similar to that, I may want the image may be given, which may be given to them, may be blur. So how do I improve the contrast and brightness of it? Then how do I identify what is my region of interest? And can the region of interest be more specific when the diagram is given? What if I'm given with multiple different pieces of the same image? How do I combine all these things? With the dark image, which are there provided to me only in grayscale, how can I make it clear that I have to pierce in only in this particular XY position? What are the changes that I can bring in? And these are some of the things that we can think, and that's what I think we are going to discuss in all these things. So when we talk about giving instruction to the robot by a human being, it's all by a procedure is what we call as computer vision. So computer vision is very simple, like how our eye scans the object and our brain immediately calculates what type of object is that. How does it do? It goes searching back in the memory that we do possess and find out what is the object that is actually mapping with our memory. The same way, now the computer wants to look into that and it has to identify with its memory. So what is that memory? That is where we call it as the data set. And when you look at what AI is, okay, and what is the benefit of AI, why everybody is talking about, I'm not going to go in detail about all these things. Okay, but a short introduction, I'll just try to cover up before moving on to some little tools or GenAI tools that we do have. So it is all talking about how a machine can act little intelligent, okay, as similar to a human being. What is it, little intelligence, right? No, always we like people who are very smart. What is it, smartness? Smartness is adding convenience to something else. No, when you are with your friend, you are feeling very comfortable. Why are they comfortable? They act in a way that you like or that you are expecting. So if you just think of out of the box, you think, what do you like in this world? When people are like, how you want them to be, we are very, very comfortable. The same way, we want the machine also, every device, whatever comes in, no, you take PowerPoint. When you choose one tool, a designer is coming on the right, okay? So automatically it gives you multiple. I'll also show you in between how I have used the designer. So it gives you a lot of different provisions of how this particular slide can be modified. So you don't need to think even, okay? Prior to that, when I want to put a slide of this kind, I need to work a lot to come up with. So that's where this intelligence is coming. If you think of healthcare industry also the same thing, okay? Earlier, we would have seen doctors looking at the X-ray images placed over a lighting box, okay? And then looking at, no, even the doctor is with a long sight, he will remove the glasses looking keenly of what it is, no? Now you don't need to bother. A simple app that is coming in your mobile app will definitely do the needful. So that convenience is what are we going to get out of it, right? So how do we set it? Okay, so always any healthcare, it's not only for healthcare, any kind of product that you're going to develop, the setting and thinking of whether are we going to achieve it is very, very important. Okay, and for that we have to actually walk in the line. So every time, can you develop a system as per your requirement? Definitely we are not able to do. That's what madam was telling in the last session. We had a very great evolution of different AI, deep learning methodologies, starting from machine learning. Now we have deep learning methodologies. It went to a next level called explainable AI. It went then to agentic AI, and it is actually evolving. So when the evolution can never stop, always our thought process should be to think of what are we actually expecting in that healthcare domain to be achieved. Is it going for, are you going for disease detection? Like, yes, whether the disease is there or not, okay? Is it what are you going to stop with? Or is your work is completely aligned with giving a better image when the input image, quality of input image is very low? That is also a great research. Okay. Or are you going to use some parameters or metrics to understand, am I doing a correct task in the healthcare industry? Like what we have suggested is what we have to actually discuss. The small example I used to give to all the people who are attending my lecture. So this is one robotic, this actually states how are we becoming experienced and how do we want the machine also to be experienced. Same way, this experience you cannot deliver. I'll come back relating it to healthcare now. Now assume you have lots of robotic restaurants that are available. This is one restaurant where they started training the robotic servers or robotic waiters. They were given the complete instruction of where the tables are actually arranged. It goes, serves the content onto the table, then it requests them to drink and coming out. This is a normal procedure they think would help the people. And it was perfectly working for the first 2 orders. Okay. Then there was a situation now. Okay. When it was walking to the table number 3, there was a kid just crossing it. Okay. Then what happens? So this robotic waiter has fallen down, pouring all the liquid items that it is carrying onto the heads of the kid which was running. Okay. Can this robot predict? You may think, but a human waiter, even if the kid just pass, when we are coming from the college to our home, there were lots and lots of cows, dogs that are standing on road. Can we run a robot on the road? We do not know. Okay, same thing happened. Now what happens? Since the robotic waiter, were not given the instruction of how to actually react when the situation is like this, it actually fails. Now, what is the learning? Now, what is that? You have set a scenario, baseline of how the system has to run. But now your task is not only to set a baseline, now you have to improvise the system. How do we improvise? Yes, this is the first failure that it met. Let's say you are giving a chest X-ray, which is they're affected with COVID, but the prediction is that it is not affected with COVID. You perfectly know that this is a wrong output. Now, what do we need to do? We have to retrain the system. What are the retraining models? When as similar to what was telling, either we can increase the number of iterations on which it needs to learn. So what does it mean? We may assume that this waiter has not learned properly, and then we may ask him to learn more and more. Okay. Or else, on the other hand, there may be a problem with your data set also. In this case, if you see, we haven't told the waiter that there may be a possibility of an obstacle that may come in. So that's what we call it as unexpected situations, which is the lack in the data set. Okay. My data set doesn't have one such kind of thing, which the system doesn't know. So what do? We increase the training data set with all the different type of possibilities, or at least with the one where you met the failure now. And then again, you start retraining the model, right? Now the same happens to the robotic waiter. Now, whenever a failure happens, the system should not, when the system says that it is a failure, it stops at that point without getting evolved. Now the people understand that yes, since it is a start or it is a fresh, yes, the problems may happen. Every time it is giving learning, and now you see it has evolved into a restaurant with complete robotic waiters. That same thing is applicable to your healthcare also. When we talk about artificial intelligence, it is a disruptive technology which actually has turned around the world into a different pace, right? So, since the word disruption makes us understand the fact that the technology is becoming inevitable and there is no apprehension stating that you can live without this AI. Any tool as on today, if you go, it is associated with one AI on its corner, right? So by one means on other. So and hence it finds an application in everywhere. And the top is what healthcare and that's what we are actually discussing about. Now, if you look at, this is the style, okay? And if you look at human learning, okay, so this is the pace on which this human beings, so this is a general style. And this can be very well mapped to your healthcare domain, okay? So what is an intelligence? Intelligence grows as the experience grow. So this stage is when you start making the system learn about the context. Then it grows. Whenever the failure happens, it learns until it reaches this particular stage. Even at this stage, we won't say that it has learned 100%, but yes, it has learned to a greater extent. Now, as this particular evolution grows and the learning curve goes like this, okay, there is a kind of data and information that you will gather for making it to learn. And through this data and information that you are gathering, you make some kind of knowledge and wisdom to be given back to the creator. Okay. So when you talk about data and information, one, we call it as descriptive, which talks what happened. When we go to a doctor, what doctor will ask? The first question is, what happened? Okay, what are you suffering from? That is what we call it as descriptive. So when we tell them that, yes, I am affected with fever and cold for the past few days, then he will ask, why did it happen? What is it? Why did it happen? Have you taken any chill food? Have you traveled along? Have you been with any other chill or have you drenched in rain? Okay, this is what we call it as diagnosis. When a description is given, the next stage of what do you call the healthcare analysis is about your diagnosis. So this diagnosis happened, and until this is what is the information that the system is going to gather from you. Okay. And then comes the knowledge and the wisdom. Yes, I have collected a lot of information from the patient who is sitting before me. Now I have to go. Then the doctor will tell. So there will be 3 more days you will have the fever because it is a viral season. And since you haven't gone anywhere for a longer trip, and since you didn't have this dysentery or vomiting or anything. Yes, okay. So the fever may retain for 3 more days. Then he will give a prescription, okay. Sorry, perspective, okay. So what is that perspective? He will tell in what way can you make yourself comfortable. What is that comfortness? He will tell like, no, drink only hot water, use only soft food. Okay, that is what we call it as perspective. And last is, cognitive. When you are able to reach this position, we say we have reached a particular context, which we call it as very general AI. Okay. So what to do, why and how. Okay. So by using all these things, I have the description of what happened to me as given by the patient. And the diagnosis is what I have, because this diagnosis, again, I got from the patient, and also I applied my mind and the experience to understand what happened. And I am with these information, I am able to predict what may happen next. Okay. And then I can give a perspective of how you can make use, that is how you can make yourself comfortable moving out from that problem, at least for a smaller, let's say, for example, if a patient is in last stage of some problematic disease which people cannot cure at all, okay? That time what the doctor would say, yes, sorry, I cannot able to do further. You take him to go do whatever it is. Okay, that is what we call it as the perspective. And then cognitive, no, he will again say like, no, let this not be you. What do you say? Keep yourself isolated from your family members because it's a communicable disease. All those things, right? And this is what we call it as an explainable, agentic, and so many other AI. And when a doctor is able to do all these things, okay, the same is what we want a machine also to do. Okay, this machine wants to learn all these of what we have described as of now. And when it is able to do, we call that as a machine learning. The machine is able to describe, get information, get input, process, predict, okay, and in the states why it happened, and it gives you suggestions of what you can do and what you cannot do, and all those stuff. And what is required for this? Yes, all of us are interested in doing a research on healthcare. Again, a question was also there from the audience to the previous resource person. Okay, so how can I do all these things? Yes, I understand that there are a lot of problems in the healthcare industry, and I'm very curious to go about it. How can I go? Okay, now, luckily, by after this COVID, no, we are not stringent in getting the data. Okay, we are comfortable enough in getting different kinds of data. Now, trying to understand what are the different types of data that you can have. Okay, one we call it as the numerical data. What is it? Numbers. Okay, for example, when we go to the doctor, initially, so don't think about I'm talking doctor. Sometimes we feel little fishy, but yes, this is actually the course on medtech, so that is the only option. So when we talk about numbers, when we go to a doctor, on the right hand side, top right corner, they will write what is our weight, what is our height, okay, what is it BMI, what is the blood pressure, and what is the sugar level that we do have. What is the representation model? It will all come only in numbers, right? The fever may be, if let's say if a patient is having a fever, it may be represented in Celsius or Fahrenheit. That is, unit will vary. And the blood pressure is how much is the systole and diastole. That is in a different style. So the unit may vary, but the representation will be in number. Then comes this kind of alphabets representation. Numbers. Yes, what are those numbers? Many times, what is the blood type that you do have? A positive, B positive, B negative, AB positive. How do we represent? It is all by means of this alphabets. So this is also one kind of representation that a healthcare system is in need of. And third is, yes, can we restrict ourselves to only numbers and alphabets? Definitely not. Next stage is moving towards having images. I'm having an Apple image. You just assume it to be having a CT scan or an MRI scan image. So image is one way of representing what has happened, and to make us understand what could be the predictive and the prescriptive actions that we can take to make, doesn't make. So whatever be the data structure, yes, we are now able to generate a lot of data, because now you see, you might have seen apps like Practo and other stuff, no? Where they are the people, doctors are using many different AI-based websites to keep their what do you call, reservations and call attempts, feedbacks, Google reviews, and so many other perspectives, right? So, and when actually we are requesting them for an appointment, automatically we are giving our information to them. It will ask what is your age, from which area are you coming from, are you do you have fever, and what for you are coming. No, unknowingly we are actually giving our own information to the system, and that's why we are able to generate a lot of big data. With all those big data, okay, so and having known about, there are buzzwords that are actually there: artificial intelligence, machine learning, deep learning, and generative AI, which becomes a subset or superset. Don't worry. What can we do with that? Okay, there are some examples of how can we easily distinguish between that. Artificial intelligence, virtual assistants, AR, VR, game playing AI, healthcare diagnosis is what we say that it comes in the AI layer. And machine learning, which directly gives you an output of what can come, what is the predicted output, yes or no, to a value within a range. These are some of the things. And a little deeper into your deep learning without worrying about how the data gets processed. If I want my output, we go for it. And last is generative AI, where we have to generate reports, right? So a typical example is we go for an ultrasound scan. They are keeping some device on our stomach or the abdomen or wherever we want the scan region to be. And they actually do some scan and they are fixing up the positions. You could have seen they are using the keypad. They will fix up X, Y coordinates and all those stuff. And automatically the system gives you a text, okay? It says there are no nodules in the blood, left kidneys are good and right kidneys are good. The liver is like that. There is a fatty one, grade 1 fatty liver, so many things. That is what we call it as generative AI. From the input, it is moving towards that. And that's how this AI is actually being evolved in healthcare also. There was narrow AI where we have only machine learning and deep learning. Now, actually, we are moving towards artificial general intelligence, where we have this generative AI, explainable AI, and agentic AI concepts. Very soon, what the world is expecting, like, replacement of human is what we call as artificial super intelligence, like what you have seen in Environ 2.0, which we do not want to happen. And there are many things that anybody has to learn, okay? Even if you want to work on AI, okay? So these are all the things, no worries. And let us move with the understanding of what happens in the healthcare industry with all these aspects, a little clear, more understanding on what is actually happening when we try to embed this computer vision concepts into the healthcare set, okay? So what is that computer vision, okay? So we are giving a machine a particular image and we want the machine to tell either the components or what is there embedded as part of a particular image. In a simple term, that is what computer vision. And if you look at, I'm giving you an example of this. So what can we infer from this? When this is plainly given to you, what is the observation that I'm making? Okay, assume that I'm a human being. My brain quickly thinks of what is available and I can able to say there exists a banana, then orange, then grapes, then apple. That's it, right? And pomegranate, and that's all. The same is what we want the computer also to do. So we give them a machine. It tries to identify. A very quick other example is, let's say if I'm giving a person who's riding in a bike on road, then it has to give me that there is a person, there is a bike, there is a road. Okay, so that is what we mean to say is computer vision. Same thing on your healthcare industry, right? When an image just like this is given there, when normally even in any device now, the habit is our two fingers automatically without any intention, it comes, it tries to enlarge. Okay, it happens on any, even if you are given with the hard book or textbook, this happens. And when we want to expand, we want the problem to be identified by the human visit. Okay, so if you look at here, this particular person would like to expand this portion to understand where the nodule is exactly in this particular position. So, and how do we do? Okay, human being tries to expand, find out what is the difference he can visualize here. The same is what we want the human brain, computer brain to do. Okay, so that is where the importance of computer vision comes in. So when do we say that we are happy? What is that accuracy level that you are getting? Generally, if you see, and will you be able to be very happy and is the process very, very easy is what we need to understand basically. Generally, when we talk about apple, we know that it is of this shape and it is in red in color. And there will be a kind of, this kind of structure that is there in the apple. Yes, the kid is able to understand that it is an apple. But what if on the next day, we are able to provide it with this kind of figure? It will be very difficult, and the child, we do not want the child to get confused. We want the child also to understand or tell the fact that this is also an apple, even though the structure is not there. Assume this apple is now cut into 2 pieces, okay? But still we want the kid to say that it is an apple. Okay. Now, this particular case, you have a lot of apples on the same branch. Yes, still we want the kid to say that it is an apple. Now, if you see here, okay, the apple is being covered with a lot of mist on top. Yes, now also we want the kid to say that it is all apples. Okay. 100% we want the kid to be efficient. Same way we want all these computer, what do you call, the healthcare figures to understand that there exists a fetus inside the scan. Now, if you look at here, it is a grown-up fetus. Okay. Now, if you see, at least you can visualize that there is a fetus. But if you look at here and if you look at here, okay, so inside the uterus, it may be a fetus, it may be a problem, or it may be a what do you call, nodule that is present, which may disturb the function of a lady. Okay, so what do we want from the human computer vision, or what do you want from an AI engineer like you or a researcher, is to understand that the real world comes with a different, plenty variety of problems. Okay, if you take the identification of fetus in a CT scan and to understand the position of it itself, it will be very, very difficult. And hence is the requirement. So how does the doctor is able to assume a doctor just passes out of his degree and comes for scanning, right? So the possibility of he or she diagnosing that either this is a fetus, whether the fetus is there provided with an ear or not, whether the parts have grown up, will be very, very little. But if the same thing is being diagnosed by an experienced doctor, she or he will able to immediately tell from where does this knowledge comes in. And how do we embed this into the machine? That's what we have to think of, right? And how does these digital images, I'll quickly move on because already we have crossed 45 minutes, I guess. Ma'am, am I audible?
Yes, ma'am. Yes, ma'am. Clear.
Yeah. Okay, thank you. So how these images are being represented? Okay, so whatever we say, it is number or what you call your alphabet, your image, your video or your sound, which comes out, okay, as an analog signal, whatever you see, okay, and these images have to be expressed only in the format of this kind of representation, because a computer by definition is one which can operate on only the signals like 0 and 1. Okay, it cannot understand. Even now, even a supercomputer cannot be able to understand. So how do you represent these digital images becomes the question. This images comes in different types. Okay, so when I was talking, there was a question by my colleague. Okay, what is the minimum level of representing an image? So what do you call as a resolution? So why do you want to have a very great resolution? When you're watching images in YouTube or anything, it is asking you what is the kind of resolution that you are in need of? High resolution or medium resolution or low resolution or HD, high density images is what are you expecting? And what does it mean? So the resolution talks about how many kind of pixels are there in a particular position. Let's say if this is an image and this image, okay, so how many number of pixels, the dots that you have on this x-axis and you have on this y-axis talks about the resolution. As you have very numerous number of pixels representing this, the representation will be very, very clear. Okay, now I will just, you see how clearly we were able to see the image. Okay, so even the hair ending is all very perfect. Okay, we can able to see even with that kind of case. Okay, and that's where we are always in need of this high resolution images. And how do we represent it? So this pixel, let's say, this is a grayscale image, meaning to say the values may vary from white to black with variety of density of your black. There is a little gray black here, okay, little whitish, and this black is completely different from this black, and this white is different, and this white is different maybe. Okay, and this white is different. How do we, this is what we call it as grayscale. and we represent the grayscale. So this particular image, let's say when it is white, we call it as 255. When if you take this pixel, when it is black, we call it as 0. And 0 to 255 in between, whatever values we have, we call those as the values of that particular pixel. So when you increase, one thing is that when you increase the number of pixels, automatically the resolution gets increased. When you increase the resolution, automatically the value will get increased. But on the other side, when you increase the resolution, the number of pixels that you want to store per image will also grow. And accordingly, the number of operations will also increase. Okay, that we have to take in mind. On the other scale, if you see, okay, so what about the color images? So it depends on what kind of color coding are you going to use. Sometimes, you know, the black is represented, these colors are represented by RGB, where all 255 and under red, green, and blue will be considered as a black. All zeros will be considered as white. So for this particular image, let's say if it is of 256, okay, what is the 256? I mean to say that on this x-axis, you will have 256. And on this y-axis, suppose if I say since the length is high, I am representing it as 512. It can be 512 images. Now, when it is color, so under R category, red, you will have 256 into 512 matrix representing this. Then the second matrix for G and the third matrix for blue. So when I'm talking about one particular pixel, for example, this corner pixel, okay, I need to understand what is the red component, green component, and blue component, multiply, and that would be the output that you will get. Okay. Same thing is what I apply that is available for your healthcare images also. So the healthcare images may come in this way, like grayscale, or in this way, which is your color image. Accordingly, we have to see. See, this is one of the Gen AI slide that I have used. When I was copy pasting, automatically by the side, the designer window will open and it give you a lot of different types, because you can see all my slides are there with the image and the title on the top and the figure at the bottom. Now there is a slide change, right? And this is what happens. So the analog image gets converted to sampling, and then you go on for pixel quantization. And that's where the figure actually, the image gets stored. And when it is color pictures, you know, one particular value may go for red component, green component, and then the blue component. Combined together is what is the value of the pixel. And it's not only RGB, there are also a variety of color coding techniques available. Cyan, magenta, yellow. It is also one kind of color coding that is available, and that's what is the image resolution we are talking about. And what about video in healthcare? Normally, we won't go for analyzing the video to a greater extent, but there are situations. I can give you one example. Normally, while people are doing laparoscopic surgeries, right? There was a case, no? Normally, this laparoscopic surgeries, they will insert one small camera, okay, over the tube to the part where the surgery has to happen. There will be two tubes. You might have, when somebody has got operated in a laparoscopic way, you might have seen that there were two holes that will be pierced in the stomach. So one hole will be utilized to send the surgery equipments. The other hole will be utilized to send the camera for visualization. The camera will go inside the particular tube, and this camera will, as it moves, it takes pics, which automatically gets delivered to the doctor who is visualizing it on a monitor. And while doing so, he will operate it and he will send the instructions to the camera to go to reach the place which he or she is actually in need of. So assume it reached the particular position where the surgery has to happen, it stays there. Now, from the next tube, automatically, this surgery equipment will be passed. Again, they will start doing the operation. But now you see, when I'm wearing a glass now, okay? When I'm wearing a glass, when I'm sitting in an AC room, automatically when I move outside or from an outside scenario, when I come inside, okay, automatically a fog will completely come. Whatever costly my, that is what you call this glasses, okay, it will be covered with a fog. The same thing is what happens to a laparoscopic surgeon. So what happens? How much ever the costly the camera is, after some time, due to the wetness that exists when it goes towards the tube, it will be covered with the fog, and the doctor will not be able to visualize that particular position. So what he or she does, he takes out the camera, then she wipes up with the liquid, then he inserts. Okay. You see, over a period of surgery for just 1 minute, they will quickly take out, cleans once in 30 seconds or 40 seconds. That's what normally has happening, as per the statement of the doctors also. Now, what is that video processing in a healthcare for that situation can do? Okay. Now, the pictures that are being sent from the camera to the doctor is continuously being monitored. And when the system can able to understand that there is a slight kind of blur that started coming, it indicates the doctor that the fog has to come start now. So what is the benefit to the doctor? Again, you may have a question of, now, okay, I have identified, the system can able to understand that the fog is started covering the camera. But again, he has to take out and do no. It's not the case. Now, what the people did or the researchers did, they have applied this image pre-processing algorithm over the image that is actually captured with the camera with slight blurriness, and then they remove the blur. They go for various other contrast brightness adjustment, and now instead of taking out the camera once in every 30 to 40 seconds, they are able to make it retain inside for 1 minute. But the 20 seconds is a wealthy case for a doctor, okay, which will save the patient from loss of lots of what do you call this blood which is going out. How does it happen? This video is not it's a continuous, it's assumed always to be continuous stream of frames. So every frame will be assessed separately and the results will be combined or overlapped, and that's what we call it as video processing. Okay. Now this is now coming to a little all these things I am just trying to tell, assuming that there are some misconceptions that happen when we talk about AI or healthcare or medtech. Okay, those are the things I thought I can make it, because you have a very great learned group of people who are coming in pipeline in the next few days. So these are some of the small things that we have to be very clear while you move on starting working towards that. And the context of what a computer vision is and what an image processing is has to be clearly understood. Looking at what an image processing is, as I was explaining you, so okay, the input to an image processing software will be an image and the output also will be an image. What is the difference? The output image is a polished one. Okay. So it may be applied with the smoothening concept, sharpening. When you are copy pasting an image onto your right, let's say, okay. I'll just show this image. When I right click, okay, I can go to format picture. Onto your right, you can see a lot of different picture corrections, right? You can increase the sharpness, brightness, contrast, all those things. So when I increase the sharpness, you see what is happening. Okay, you can see some kind of clarity. When you decrease, it becomes blur. Okay, and accordingly, you have variety of things. When I want to, so for this image, this brightness is valid. Okay, but for different images, depending on the context. So these are some of the operations that we do on a normal basis, which we want to do under the image. These are what we call as image processing. And when we look at this compression, okay, this is also one thing. Okay, contrast and then watermark removal. Yes, sometimes, you know, we all will held up with the watermarks. Okay, brightness increase. Then edges, identification of edges. Okay, edges are the segment output of the segmentation, right? we want to focus only on the particular area of the image. I don't want to disturb other images. Okay, so those are the things that we are actually looking at. So this image processing is an area of AI. Okay, it's not necessarily to an AI, but it was embedded since it is also giving you a comfortable image for you to process. Okay. So this will take an image as input and will give you an image as an output. Looking at a consolidation of what is the difference between this computer vision, or we do not exactly say that it is a difference, but a little understanding of what image processing is and what a computer vision is. This side we have input and this side we have output. When the input is an image and then output is also an image, we call that as digital image processing. As we saw, brightness, contrast, sharpness, smoothing, compression, rotation, translation, anything. Image to description is what we call as computer vision. What does it mean? I'm giving you an image. You tell me whether it is a dog or a cat or what kind of apple is it. Is it a chest X-ray or is it a breast cancer X-ray or breast CT or what it is can be told by computer vision. Then when you are giving description as an input and we are asking that, because many times, the ChatGPT will type, I am in need of a picture, okay, to represent or to celebrate the birthday of my son. Okay, automatically it gives you an image. And this description to image is what we call as computer graphics, which is nowhere being of interest now. And last is description to description. And that's what we call it as artificial intelligence is all about, where you talk about agentic AI, you talk about generative AI, you talk about explainable AI, everything comes in that particular situation. And some of the slight image processing techniques, which can be very of unique importance to your healthcare industry. Okay, initially image acquisition and then image pre-processing. Okay, so this pre-processing includes all type of adjustment. Normally, when compared to other images, this pre-processing is slightly of very much importance only to the healthcare industry. Then comes the segmentation. Segmentation is you need to actually separate out the region of interest. Okay, I'll tell you the reason for what it is. For example, I have an image, okay, which is taken from my I have an X-ray image of my right leg. Okay, so the posture is taken like that. Okay, and I have a leg. This is, you assume that this is a leg. I'm just drawing. Okay, this is one particular image. Assume I also have another image. Okay, but the leg is slightly on the right hand side. Okay, so there is no problem since these are two separate images. And when I look at image 1 and image 2, this is image 1 and this is image 2. When I look at both the images separately, you see I'm okay with both the images. But now there are so many different algorithms that come in to make the data balanced. We'll let you know. One example is, one thing what it does is, it just separate out one portion of this image and adds the same portion of this image to that. Okay, that is one kind of algorithm that people use. But now you see, if the alignment is like that, once the synthetic image gets generated, you will have two legs on the same photo or the image, which is not logical to proceed with. Okay, that's where the image segmentation is very, very important. This is one thing. Another thing is, we are not interested to understand about unnecessary context that lies in the other places. Our core area of interest lies only in the understanding of a nodule at a specific region. I'll try to rotate, find out where exactly it is, under which rib that it is. To that specific level we want to do. And what the segmentation does, it actually shrinks that particular image into a smaller image, which only has this particular leg. Similar way, this will also get changed into this kind of image. Now, when you do segmentation and overlapping, automatically we don't get into problem. That is an advantage. Then we have lots and lots of other things, filtering. Okay, I may want to take out only the region of interest, removing all my background. Okay, and then denoising, image registration, and image enhancement. All these things are pre-processing steps that we can do. For segmentation, again, you have a variety of segmentation algorithms that you have. We can use any of that. Once all this image pre-processing on a healthcare data set is done, this is the first step. Initial step is how do you actually acquire the data set, okay? Let me spend some 1 minute of time on that, because somebody was asking it, okay? Generally, if you go for a healthcare data set download itself, we have now, people have given lots and lots of healthcare data sets. No, Kaggle is one specific repository where you have hundreds of image data sets that are available. When you are not specific, you can just go talk about healthcare data set, okay? And inside, let's say if I'm concerned with skin cancer, okay, you can see the skin cancer data set. When you log in, automatically you can able to download the data sets, okay? You can see malignant or skin cancer data set which is available. So view the data set, okay? You will have lots, see this kind of images you will get. And there are 360 files in the benign form, 300 files in the other form, okay? You see, these are the different images that are being provided. You can download and you can make use. This is Kaggle. In Kaggle itself, you have a variety of images that are available. Apart from this also, you have a lot. Now the government itself is giving a lot of, now you see the government of India itself is giving you a lot of data sets. Then this, here also you have 21,992 data sets are available. If you look at this ICMR data repository, now lots Indian Council for Medical Research is now providing lot of funding and is raising for lot many calls for doing medical related, because the now requirement for this medical industry has now moved to a greater extent. So that is what we need to understand. And world is in need of engineers like us to do research and then do. Now, once this pre-processing is done, the next step is how do you realize whether the given particular image is malignant or benign, or what kind of problem are you, a grade 1, grade 2, grade 3, grade 4, grade 5 kind of the diagnosis that you want to do, okay? That's where comes your machine learning and deep learning. So machine learning you can use when you do not bother, you are going to give exactly the features, and when you do not want to bother about the features. See here, the feature extraction is given by the developer. That is the only difference. Here we do not bother. We'll just say give the image and we will ask what it is. Okay, we'll just give the chest X-ray, yes or no. The entire feature selection, extraction, and then classification model is what the deep learning does by learning of its own. It is like this now. Instead of spoon feeding a guy, stating that this is what is the procedure to learn a particular course from start and end, it is like throwing it to them, asking them to think of in their own terms whether it is right or wrong to end up with the solution. And in either case, it is little difficult in the healthcare industry. Healthcare, yes, because when I think last session, someone was asking about false positive. In healthcare industry, all of them are very, very difficult. And it is not correct to manage or to have false positives. And it is more and more critical to have false negatives. So what is it false negative? When a patient is affected with COVID, but the system doesn't able to recognize that he is diagnosed with COVID, what will happen? This guy will go roam around, try to spread the problem to so many other problems, which causes life critical problems to many of them. So false negative is very, very important thing that we have to first take care of when you are working on the healthcare data sets. So if we say like so, is false positives okay? But no. Madam has given a very good point on that. When a patient is not affected by COVID, but when he is diagnosed as COVID, yes, the seriousness of the problem is not will not persist in a greater sense like your false negative. But you look at the individual's perspective, if they are given medication for a longer period of time or towards a particular period of time because of this wrong sensation or wrong identification, it may affect their health, which may provoke other diseases nowadays and which may also result in a problem. So that is where we say both false negatives and false positives are to be taken care, but the priority has to be given to your false negative. For want of time, I'll quickly skip all these things. These I have to show you the fact that it is very difficult and you cannot complete this in one step. You need an sub-function to be created, okay, to get the process as an output. That's where is the introduction of this multi-layer perceptron. Then comes your CNN, okay. And this is your evolution. Initially, the development has started with perceptron, okay. So then artificial neural networks came in, then came your convolution neural network, then we have recurrent neural network. Then this convolution neural network, we have to actually given the number of layers of convolution and pooling that we are going to use for the particular problem. Every time we need to define. And what this XNet architecture does, okay, researchers have done so many different experiments or researches, and they understood that a combination of 15 or 100 convolution plus 90 pooling is what always gives us a better solution. And it was given as one architecture like XNet, VGNet, AlexNet, GoogleNet, and all those stuff. So they are same as your CNN, but with the restriction that the number of convolution and the pooling and the pattern of having that convolution and pooling little differs when come to individual XNet architecture. Then the next evolution is what is transfer learning, where we do not bother about this training period. I'll just start with the weights of the architecture, that's it. Then it has moved on to generative adversarial network, okay, where we would like to generate more synthetic images and we start working on. And these are some of the platforms that you have to be aware of when you start working on in your healthcare research. Okay, so the one Theano, TensorFlow are all the frameworks. On to the right, you are in need of GPU and TPU to process this much of data. And these architectures, I hope you have been given explanation about. I'll skip all these things. I'll just in another sometime I'll talk about the challenges, and then I'll just show one simple that tool, AI tool, which you can use without much worries. So why do we consider this as a greatest challenge in a healthcare industry? Okay. One, the first thing is, first thing what we talk is insufficient data. You just see whether anybody will be interested in providing our own personal data to anybody, asking them, even a patient, okay, who is going to, who is there in the verge of the last days of his life, will not even think of to actually, what do you say, share his information to anybody. There are lots and lots of reasons behind. The legendary might get affected, or the individual's ego might get affected when it is shown to somebody else. Their life is going to be a question mark. So many different reasons of that. But all these things create a scenario because the artificial intelligence, as how a human being is gaining experience throughout his lifetime, this also takes data. Only with the sufficient amount of data, the machine can get trained in its proper way, and then it can come out. This is one greatest challenge that everybody is facing now. Second is imbalanced data. This is one we have to very clearly identify, because the research can end up only by saying that I have employed these many techniques to make my data balance, and this is what is the result of the outcome. Now, if you see imbalance data, now out of the 100 patients, okay, visiting the hospital for a particular disease, we want only a very minimal number like 5 or 6 to be diagnosed with the disease. We want all 95 to go out very casually, and that's what happens in all cases. So what is the ratio of the data set? It is only 95:5. 95 of normal, okay, and then 5 of this malicious, okay, is what you have. So when you feed this into the system, what the system can understand is only about 95 normal images, and this 5 malignant images will not even be considered by anybody. Okay, so on the other hand, only if you have a very large patient data and the number of normal images are very low, the system will automatically get trained on the negative side. So to a machine which is actually get trained on this way, whatever input you give, it will get biased over this normal image. It cannot tell you whether it is this or not. So this is the major problem that everybody will be facing in the healthcare industry. Even though if there are a lot of techniques that are available like SMOT, undersampling, oversampling, okay, cut mix, so many different algorithms that are actually evolving for the sake of increasing the number of images which lie on the lower end. Still, this is also one kind of challenge that everybody face. Okay, so and we need to take care of this first. Third is the data privacy. Yes, as we were discussing, okay, without even knowing their comorbidities, okay, their history, how do we can able to understand or how do we predict that there is a possibility of having diabetes in future, there is a possibility of having a cancer in future since your generation as so and so, okay. So those health records are not sufficiently being managed in India, and that becomes a problem and nobody wants to do. Then if you look at this intrinsic view, okay, so due to the want of patients and these number of specialists, the unavailability of specialists that are there in the particular domain, people are not able to feasibly understand the intrinsic information that has to be taken care by the doctors, and that's where is the problem that results in some few cases, okay. And last is no, the data is not belonging to a particular one single type. Rather, it's a multimodal data, meaning to say that sometimes you will have the blood test with numerical values, the scan reports with text, unorganized text, then the images that comes in this ultrasound form, MRI scan or anything, and you will have the video that this fetus is actually giving you. All these things has to be analyzed as a whole, and the result is what we have to give back. And that is what is the difficulty that we have. Okay. And with that, no, I'll just show one simple example of this teachable machine. What I did is I just went for searching this COVID-19 data set. Okay, I'll start fresh so that you can just understand. This is only for the beginners. Others, sorry, kindly excuse. One is COVID data set. Okay, this is what I would like to download. The first is what I have visited. So there is a COVID-19 data set. Okay, when I download, it gets downloaded into a archival like this. Okay, COVID-19 data set. When I expand, there were two folders, train and test, as usual. When I look at train, there were 3 classes. One is normal. Okay, these are normal chest X-rays. You could see that around 97 normal X-rays were there. And the next is viral pneumonia, not like COVID, but they have viral pneumonia. 96 images were there. And you see COVID images, there were 38. Right? 38 of the COVID infected X-rays are given in the train folder. Another one is for testing. Similarly, we have COVID, you see, no, some around 4, 6, 8, 24, 26 are there. So This data set is what I have downloaded. What is that teachable? So this is what is that COVID data set. And once this is downloaded, I have gone for this teachable machine. Okay. What this teachable machine tells you, because it was given in my topic. When I was exploring, it was pretty easy for the beginners to start with and those who were not aware of writing the coding and to start with. When you are not aware, I prefer going to Kaggle. I'm not sure whether you people are aware of this or not. One, it is this Kaggle not only provides you the data set, but many people has already shared this particular code here. You can go in any of the code, okay? And it is not anything wrong to go use their code to learn. It is only illogical and unethical if you make use of the code for your own self-purpose. But for learning, everybody uses this kind of material. And we can improvise on how we want it to be. Now, if you see, the entire working procedure will be explained by those people who have contributed the code to this repository. And you can just go through. And if this is not of use to you, you have variety of other notebooks that are available. And that is one way to make you learn. Other thing is what this teachable machine. I'll just go get started. Now I'm going to create an image project. Okay, I'm not going to use an audio project which will convert your signal to value. This is posing. Posing is, human movement analytics. Okay, like whether if you're doing pose yoga, if you're dancing, whether your posture is correct or not. That is what is the pose project. I'm interested only in this image project. Okay. Now standard image model, embedded image model, embedded no like IoT. I'm interested in only the standard. Now what is the 3-step you can see? First we have to upload the images. Then I have to go for training. Then I have to use the test images to see whether the training has been done properly. What I will do, I'll just open up here and see how many classes I do have. I'm going for training, COVID, normal, and viral. So what I do here, I'll just upload. Okay. So we can drag and drop the images. I'll first go to training, normal images. For sake of simplicity, I'll just use 10 images. Okay, then open. So those images will get uploaded. Now I'm changing this class name to normal. So what I did is first class is normal and these are 10 sample images. Then next is viral fever. So I'm uploading the images from the viral pneumonia folder. Same way I'll upload some 10 images. Yes. Now I have one more class. So I'm adding the third class and third class is COVID. And I'm just uploading the third one and I'm uploading again 10 images. Okay, so I have completed uploading all 3 images, normal, viral, and then COVID. Instead, when you are actually creating a data set in the real time now, you can go to webcam. Okay, start taking a picture and then you can do. Next comes your train model. You have some parameters you can check. Epochs are the number of iterations that you start doing. So you can give 50 iterations. You can change it to 75, then 125, then in order to improve or boost your accuracy when you feel it is not there. Then batch size. After how many number of iterations do you want the system to change the learning rate is basically what we say. So, and then comes the learning rate. Okay, what is the learning rate you want to provide? Meaning to say how quickly you want the machine to learn. Okay, 0.25, for example. Okay. So once everything is set, I'll just give training data. I'm loading it from the file. Okay, so now I want to test the model. I have uploaded the images. I have given the training. Okay, now I'm going to take one test image. We have another folder called the test. I'm loading an pneumonia image. Okay, for example, 114 is what I am loading. You see, it is showing that there exists COVID. Okay, so this is completely wrong. Actually, I have uploaded only the viral pneumonia. Let me see whether any normal image is wrongly diagnosed. 120. I don't know whether it will. All 10 samples. So now it is giving us a wrong result, like all the people are actually diagnosed with COVID. Okay, let me try something else. So we have to increase or decrease the models, and we have to reduce the learning rate 0.001, 0.01. Okay, and then I'll make the system to learn again. Now when I'm going for normal, yes, now it is actually getting reduced. So likewise, we have to improvise. Now you can increase or decrease your learning rate 0.001, and we can increase the number of iterations to better learn. Now when I'm giving an image, now you see the normal probability of being normal is 85. Okay, and this is what is the play that you can do. It is actually doing a simple CNN model to end up with an outcome. And the probability of having viral is 13%, and 2% it says the probability of COVID is. So maximum is what we say. So when you increase the number of epochs, maybe it may or may not change. And this is what is the play that we have to have. And this is one simple tool which I think the organizers have comfortably arrived at to make you understand that anybody can start working with the deep learning in the healthcare. All that what you need to understand is there are open source repositories from where you can download the data set, divide it into training and testing, and then you start using this teachable machine tool to understand how this epochs and this learning rate, batch size all gives you an impact on the output. What kind of output are you planning to get is what you can think of. And once this is being set, okay, you can actually move, and then yeah, so this viral pneumonia is what I have uploaded. Now it is showing 73% accuracy. And this one we can slightly play around, but once this environment is set, you can install Python Anaconda, write the same code, whatever is shown on the Kaggle in Python, and to start continuing your work. With that, I think I have just shown you a glimpse of how the healthcare is moving towards an AI, and how is it going to impact the life of us in the next few years. And this is my contact, and if you are in need of, you are most welcome to send your queries, and together we can learn always. Thank you, and any queries, we are happy to answer.
Thank you, madam. Such an eye-opener session for the beginners. And Thank you for your time. Thank you for the efforts you have taken to make this presentation much interesting and as well as informative. Participants, if you are having any doubts or need clarification, kindly ask now. Unmute yourself and ask.
Any questions you can ask? How can get the scoliosis data set?
Polio. Not sure. I'll just check and let you know, ma'am, because till now I haven't gone to such kind of data sets for the disease. I'll just check if it is there. I'll just give it tomorrow. I will inform to madam if I'm able to get something.
Madam, how can
I
we
think there is something in Mendeley. You can check Mendeley data. I have spondylitis and then normal vertebrae images are there available in Mendeley. You may, I'll just share. I just have Googled. Mendeley data is there.
says that it is a kind of spine deformity data sets, right? The
Huh?
images
Pardon, ma'am?
of images for spine deformity, particularly
Okay.
related to spinal cord disorder, I think.
Yeah, that's what. I think there is a data set for that. Is it not what you're asking?
Yes, ma'am.
Mendeley is also one repository from where you can download. You can download it in free. Only thing is, whenever we use no, we have to give the credit to the people who have created the data set. And now all AI tools you can use very well for the comfort of a clear understanding of that. It is that we should not use AI for to an extent which will explore or exploit ourselves. That's the only thing. One, if any pap smear images, the source from where you get, okay, all these things are very easily the ChatGPT can generate the links. And don't rely on the procedure of execution from it, but we can always make use of the AI tools for our clear understanding purpose. Can beginners who do not have any computer background can use this? Yes, that teachable machine is one thing which anybody can use. It's a very comfortable drag and drop, not even drag and drop, just you have to upload the class level images and then you can train, play around. And it is very, very easy for anybody to start with. So that anybody can use.
How can we validate the efficiency or performance of these teachable machines, madam?
This teachable machine is one tool which we can use only when we start working on the platform. It should not be considered because it doesn't have the flexibility to make your model change in as easier way as we want. Let's say I may want to drop out some 10 layers from my CNN model and then move ahead for next convolution and pooling, which is nowhere possible in a teaching machine. So this teachable machine we can use for our learning purpose at the initial stage. So that will only be very useful. Otherwise, the other things, there is also for learning that neural networks, we have that TensorFlow. That one playground is there. That is also there that you can make use of. Playground.tensorflow.org. So that is one. I'll just text in the chat that tells how you can make use of the TensorFlow to change the neurons and its output. Okay, you can just increase the number, reduce the number, you can play around and arrive at a solution. So that also we can make use of to start with.
So TensorFlow will be the better Python framework for starting our.
Yeah, that is a Python framework which is preferably being used. Keras and TensorFlow and sometimes PyTorch is what are the frameworks that we normally use. Generative GAN, mostly we will not know. Let's say this cooking up of data or then creating synthetic images, one has to be very, very careful when it is coming to healthcare division because it is one's individual data. One chest will not always be equivalent to, even if my son or daughter's image may not be the same or the structure may not be the same as mine. So when we are generating synthetic images in healthcare domain, we have to be more cautious and careful. So when we try to use generative adversarial network, which pulls in our own information, tries to create more information out of it, similar to how a person's face is coming out with bird and then wearing glasses and other stuff. Sometimes it may be helpful, but mostly we cannot validate the correctness of it. So if it ends up with a risky scenario, then it's a life critical solution. So generally, from my perspective, we will avoid using it. So other than the cases where it is of most importance, and it's the only solution that we have for generating the synthetic images. Otherwise, there are many pre-processing activities like rotation, translation, basic pre-processing activities, increasing brightness, contrast, and this patching of images and are of the same images. Many techniques are there that we can make use of.
Any more questions, participants?
Any other questions? Shall we conclude, ma'am?
Okay, ma'am.
Thank you so much, ma'am, Supana ma'am, for your wonderful presentation. Hope the participants would have insightful sessions today, both the sessions.
Actually, the way you have demonstrated from the data set and how to train the models, it was very interesting and beneficial to the participants, ma'am.
As one of the participants also said, like, it was simple and clear. The explanation was very simple and it was very clear, and it will be easy even for the beginners to just know from your presentation, ma'am. Thank you so much.
Thank you. Thank you all for the patient listening, and thank you organizers for having spent your daily evening schedule for organizing this. Yeah, thank you so much.
Thank you, ma'am. Thank you so much. Good night.
Pushpa ma'am, you can
Yes, ma'am.
you can conclude, ma'am.
Okay. Thank you, ma'am, for your insightful presentation on AI image analysis, which was very informative and engaging. Thank you for the clarity and depth also, ma'am. And you have provided practical examples that demonstrate how AI is used in image analysis today. Thank you so much, ma'am. Thank you, participants, for the.
Thank you.
Thank you, ma'am. Thank you, participants. With this session, we conclude today. When we come to the end of the day, tomorrow we will have a more informative and useful sessions. We will meet at 6 o'clock tomorrow. Thank you. Good night.
Thank
all.
you. Participants, fill up the feedback form and then you can leave. Thank you.